At my control. There we go. Okay. It says we're streaming. It says we're recording. We're good. I'm about to post this on LinkedIn. I know that the logo I use for my company and the logo I use for Kanji Coder are the same right now. And I'm just gonna keep it that way because I think it'll be interesting to see like which logo starts to be known for what. Like you know, if like depending on what you think the logo is, shows kind of like how you know me, you know. And I think that could be kind of fun, so I'm going to go with that. Now, obviously, once I post this, it's going to give away the job history where I kind of post that I'm working at this company, but it's actually my company. I don't do anything stupid like list myself as the, what do you call it? As like the president or something, right? Because if I wanted to work at another company, then I would have to not make it so obvious that this is my company if I want to use this as a resume filler. But you know what? We're gonna screw that, and we're gonna slightly burn that bridge, or we're gonna singe that bridge a little bit by posting this post. Where if somebody does their due diligence, it's not going to take much to find out this connection. But I think that the benefit of posting this might outweigh the negatives, just because I know these posts get like a whole bunch of views. Well, not a whole bunch, but like 35 views. And so I think this could be a potential avenue to get other people looking at the stream. I don't know. Maybe not. Maybe everybody will be like, whatever, you know? But anyways, let's look at this post. Hey everybody, I found this cool version of C++ where they were able to get rid of a lot of legacy cruft. It really helps facilitate the construction of straightforward, easy-to-follow code with minimal physical and mental indirection. They call it Pure C, and I'm streaming it live on Twitch. So, Pure C, Plain C, C Prime, Godfather C, C++, CPP, C++. So the idea is, right, it's a joke. It's a joke, but it's deadpan humor. But there is a problem, and Hirosa, I don't know if I'm pronouncing his name correctly, on Twitch, decided to use this kind of thing called Pure C when he's advertising doing C code, just because when you search for C code, a lot of times you just end up with C++ in search results. And so you gotta wonder if the lack of popularity of C has to do with search results, and has to do with when people don't know any better. They're like, oh, do I want to use the C or do I want to use the C++? Well, obviously you want to use the better thing, right? You want to use the plus plus thing, right? So I think that's where a lot of the... I could be wrong. Maybe the popularity of C++ isn't due to that, and it's just a better language overall. But I doubt it. I really think that... I believe in like the butterfly effect in chaos, and how like little things like this could matter a great deal. I also think people follow the path of least resistance. So, I mean, there's obviously two paths of least resistance here that would force people into C++ instead of C. In fact, I did C++ first before I moved over to C. I had to go C++ to Golang, learn that Golang was basically a modern C, and go, maybe I should just do C code. Because when I was doing Golang, they did object-oriented code in Golang, but they did it in this weird kind of way where I'm like, that's kind of weird. And it turns out they just did an object-oriented pattern in a non-object-oriented language. Golang is not really quite object-oriented. It kind of is, it kind of isn't. It's like this weird hybrid somewhere in the middle of, you could say it's kind of in the middle of C and C++ in a lot of ways, in how you handle object orientation. And I kind of liked that. And I'm like, whoa, you can actually do all this object-oriented stuff in C? And I'm like, no way, really? And I'm like, okay, well, if that's the case, let's just strip it down and let's use a simpler language. Because I already make things complicated enough, right? So why not just use the simplest thing, right? Use the simplest tool for the job, because you already make things complicated enough. It's like whittling a elaborate sculpture with a pocket knife, right? You're already going to make the sculpture complicated enough. Let's not make the tools more complicated either, right? That's kind of like how I think of it. And maybe that's just an artist mindset. I also did the same thing in art school, where it's like I didn't like all of the fancy tools. I like to just kind of stick to either pencil or pen and use that to sketch out what I wanted to communicate. Alright, so let's go. Let's do this. Let's create this post, and let's just keep on coding. So, post. This cannot be undone. It's posted. Done. Alright, oh, I love that logo. Look how nice that looks. Okay, let's roll, let's roll, let's roll, let's go. Okay. So, in here, we were writing a unit test in a data-oriented design kind of style. So we create like a nice little table here of all the test cases, table UTC for a table unit test code, the number of test cases, and the number of data points per test case. And we can make sure that this macro is correct. So let's highlight this macro with purple. Let's just go up and make sure that it is the second macro in here. Yeah, so the number of test cases and the number of data points for both tests right now are the same, because we're just kind of like making the tests very basic right now. And we're going to go back and revisit them later after they're kind of stubbed in with the most basic behavior. We're doing this because we have a lot of loose ends in our code. We really shouldn't have done it that way. Ideally, when you're writing your code, you want to write a little bit of code, test it, run it, write a little bit more code, test it, run it, etc., etc. Keep on going like that. And the reason for this is because we're using C, and there's always the potential to do some type of weird undefined behavior where you can completely shoot yourself in the foot, where your tests are not going to catch what you're doing, right? And you're just going to introduce some type of erratic behavior that it would be easier to catch now than later, right? So if you add a few lines of code and then you run and something really weird is happening, you can kind of inspect those lines of code and see what's happening. Now, it's a very paranoid approach to programming, but you got to remember that as we code projects, they get bigger and bigger and bigger and bigger, and eventually you can't fit everything in your head. And you need some sanity of mind that everything is correct. So to go slowly and carefully is the way we need to do this. Okay, so let's actually look at the second piece of test code and be like, is this correct? So we got the test index, the base offset for the test data, and the maximum index for the number of test cases. The maximum index being an inclusive index, right? So we take the length minus 1 to get a maximum index. You notice that these are int32s because it's test code. We don't really care about saving our bits. These types here are 8 bits because it's the size of the data for the actual functions we need to call. Same thing with the global tx and global ty. These are 16 bits, and you know what? I think that global tx, global ty may be a signed value now that I think about it. So if we look at these functions here and check out their definitions, we can see. Okay, so use 16. So we actually used unsigned 16. So I don't think that's a good idea. I think that 16 bits, 8 bits is not enough for the global tx, ty value because it's going to be between 0 to 511. However, 16 bits is way more than we need. So if that's the case, then why not make this a signed value? Because we already have more bits than we can use, so why not get the safety of having negatives so we can see when things kind of like went wrong. And let's kind of look at some of this stuff. And we even had an int16 GTX over here where we're kind of like doing the signed math. So I am kind of skeptical of like, why did I decide to do that? That doesn't seem... This seems like just adding more problems for no good reason, now that I think of it. Can I think of any reason for why this would be, why we would want to do this way? Can't really think of it. I think that whenever we see the global tx, global ty, it makes more sense to actually make this a signed value. And we might want to kind of look around, well, okay, where else are these functions being called? So we want to take this function here and just look around for kind of where we're using it. And right now we're probably only using it in the test code, right? Like global tx, global ty, it's probably just in the test code, yeah. So this thing, yeah, it's only being used in the test code. So that's good. We don't have too many sites that we actually have to change here. But yeah, we should just change those to int16s. I think that we're going to get a little bit more safety from making these signed integers. So the global tx, global ty, we're going to change those to int16. And also, this expected global tx, expected global ty, that is already a horrible, horrible mistake. Because if we only used 8 bits, all of our test code would come out wrong. And this is what I'm talking about of, I really don't think it's a good idea to be writing these tests right now. We should really write these tests after the code is all finished. And a lot of people say, no, write the test first. But the thing is that there is an absolute certainty that in my test code, I'm going to make errors in my test, right? There's nothing like magical about test code. It's still code. So your main code and your test code, as far as I'm concerned, have the same likelihood of having errors in them. And the benefit comes from them kind of cross-checking each other. And once they agree, then you have the sanity of mind that your main code that you're testing is correct. But when we have bugs in both the code we're testing and our test code, and we're doing this both at the same time without actually running it, this is a bad idea. Okay, so let's take a look at these and see where else they're used, and see if we're using them improperly or assigning them to something improper. So right now I see an obvious mistake here. We added all these trap values, and we looked at these, and we were like, oh, int 16, right, or uint 16, all right, awesome. Let's do the same thing for everything else, and then we kind of screwed that over a little bit. So this int 16, we need enough to accommodate everything in here. So this does actually need to be an int 16 if we're going to make these int 16s. And then we're going to have to downcast these after we extract the values. So right here, these trap values are kind of bogus here, where they're out of range, right? These trap values are out of range. All right, we can only go 0 to 255 here. So we might as well do like, I don't know, how about 11, 22, 33, 44, 55? I don't know. They're not really very good trap values anymore because now they're in a valid range, but the data type is not going to allow us to go as far as we're going, and we actually had some overflow there that may have not been found if we had ran this, just because we have we don't have W conversion turned on our compiler settings right now because of some libraries we're using. And we need to fix that eventually, but it's going to be a huge undertaking, so you just need to be kind of careful. Okay, so we got all these trap values, then we're going to assign all these. Now remember, these things need to be downcasted, so we need to change these to U08 right here, right? And then over here, we're going to need these to be int 16s, which they're already int 16s, so this doesn't really change anything, but it's good to kind of formalize what's going on there. We might want a visual break between that, so we can kind of see that we have these different data types here. I don't know. Maybe not, because we have these sequential numbers here. It doesn't matter too much. Or, since these are already int 16s, we could do this, and then we have kind of a visual grouping here, and then we also have a visual grouping between here and here. So you notice I'm going to spend a lot of time thinking about how my eye flows over the code, because there's two compilers. One is the computer and one is you. So if we make it so that your eye can immediately find things that are out of place visually without having to logically process it, then you can very quickly process the code and find mistakes in it, right? You're like your own linter. One other check we want to do here now is, let's say that we overflowed, right? In our test cases, we used values that overflowed. How are we going to check that? So the first thing I see here is this global. Okay, the globals are allowed to be 256. They can be in that range because they're in 16. But let's say that we accidentally overflowed in our test cases. We want to make sure that we don't do that. So in here, we're going to make an assert. And for the inputs that we just grabbed out, we're just going to make sure that these inputs are equal to these in here, right? So we're going to take like int 16 casts of these. So we're going to take like an int 16 cast of each of them, and we're going to compare them and make sure that they are actually equal to each other, right? To make sure that there's no kind of overflow. Now, so we could do this, and this table, right, should already be full of int 16s, so we shouldn't have to worry about that. We just want to cast this side that we already grabbed, and then grab these again, right? So it's very redundant, where it's like, you know, you may think that it's kind of stupid, but it can actually save us, because I have had problems like this in the past where passing the wrong number of bits to a function, or using the wrong number of bits in a calculation, can really screw you over. So we're gonna use this kind of double checking here, and we're just gonna paste this like 7 times. So 1, 2, 3, 4, 5, 6, 7. Then we're just gonna copy everything over, right? We're just gonna take everything over here, and actually we don't need that. We actually just need these offsets to the different pieces of data. And then we need the actual names of all of the data. And I see that we kind of... Did we spell this wrong? Yeah, we actually are missing the input part. But yeah, let's just take all of this right here. Copy and paste that there. Okay, there. So now we have some checks to just make sure that, you know, detect integer overflow, right? So we can take the video integer ID here. So video... integer ID right now is 0070, so it's the 70th video, and the time is 0 hours, 16 minutes, and 22 seconds. And then we can restate for the camera what we're doing here, which is check for integer overflow. Right, that is what's going on here, right? So we have a lot of redundancies here, but it's test code. We expect test code to be very redundant, very repetitive, because it's test code. Okay, so now we have some input values and output values, and we might want to just make sure that, you know, are all of these outputs and inputs, you know, in the order that we expect them to be. And actual TX, actual TY, this looks good over here for this error checking. All of these things. Now this expected global, what's up with that? Expected global, well, this is an output, an expected output, so that makes sense. These aren't going to be fed into the function. We're going to take the actual global that's going to be fed into the function, because these are output parameters. See the address right around them? That looks good. So now that I see that we've made all these changes, I'm going to say that we have a mistake in the other code block. So we need to take all of these kind of asserts here, and we need to kind of scroll up to the other block of code, where it's, instead of paint pix to global pix, it's glock pix to paint pix. So it's we inverted these two things. So glock pix converted to C2 paint pix. And we need to fix this around, because this is wrong as well. So we see that these are U16s. We actually want these to be int16s for the input for the global TX and the global TY. And anywhere we see these globals, we want to make sure that we have int16s. Now this table, we want to make sure that we use the highest bit width for everything. So int16 will encompass the unsigned 8 bits as well as, well, the int16s. So that looks good. And we also need to, once again, check for integer overflow. So we're going to put these asserts in here into our test runner. This is basically a test runner, what we're designing here. And these names here are all incorrect, right? Because we kind of changed what was the input and what was the expected, right? Like this is called input tile quad, but in this test it's called expected tile quadrant. So we're going to take all these tests here, or not all these tests, but all these data points for the current test being ran. We're going to paste them right down there, bam, and cast them to the int16, and then we're going to compare them to these int16 values, right? So they're still aligned in the same order, but we want to make sure that these were not accidentally, when we downcasted them, we're hoping we didn't lose any information, right? And we would lose information if they're outside the range of their respective types. So now that we have these expected and actual values, what we can do is put a formal cast on them instead of implicitly cast them. So these are 8-bit, and then the global value is a 16-bit. And the reason for that is because we're partitioning this 512 by 512 section of data, and 512 is obviously more than 255, so we can't use 8 bits if we want a global pixel position somewhere in this data. But everything else is within 0 to 255, right? Because this 256 block here, to address this 256 block, we use the addresses 0 to 255. So we have just enough room for 8 bits to address all of this space. And that's why we have the mix of the 8 bits and the 16 bits. There's no such thing as a 9-bit, right? Because technically all we need is 1 extra bit to get up to 512. But there's no such thing as a 9-bit number, right? Everything is a power of 2. Okay, so looking at this, we recasted this to check for integer overflow. So we could also say that at vid IID, and the video is number 70, and the time is 0 hours, 20 minutes, and 50 seconds. And we can restate for the camera that we are checking for integer overflow. Okay. Now that we are checking for integer overflow, that's good. We may want to also add a little bit of extra space here, which kind of sometimes makes things confusing when you have this comment here, and it's not directly glued to the code it corresponds to, but we have video documentation, so let's kind of leverage this new technology of being able to stream the coding process. Also, I do like the visual space between here, having the white space between here and here. Just makes it easier to look at the code when I'm not using any fancy syntax highlighting. You see, most of my syntax highlighting is just, I can see numbers, and then everything else is white, except for like the comments are sometimes colored. And that's very intentional because a lot of times I don't want the syntax highlighting to tell me what to look for. I will tell the computer what I am looking for when I'm looking at this code. So if I want this highlighted, I'll just highlight these things, right? If I want this highlighted, right? If I want to like spot check things visually and make sure that, you know, everything is where I think it should be, I will do this, right? And I'll actually highlight things to bring attention to them. But otherwise, I'm not going to have a smattering of random rainbow colors all over the place, because most of the time those colors don't matter. Most of those times those colors are just random noise. Like if you spell a keyword like integer improperly, yeah, your compiler is going to catch that. It's not a big deal. I don't need that to be colored, you know? And now if you're new to a language and you're not used to, you don't know what's a keyword, you don't know what's not, then yeah, I can see the benefit to syntax highlighting. But besides that, syntax highlighting sometimes is a little bit too much visual noise as far as I'm concerned. So we have these casts here. We have these asserts. We have this table stuff. We could also kind of visually line this up if we wanted to, so we can see that we're kind of grabbing these values and then we're kind of testing them immediately again. I also see that we kind of have a different formatting scheme here than over here, don't we? And we should probably be consistent with whatever formatting scheme we choose. And there we go. So now we can kind of see a clear pattern between these two blocks of code, right? We have a visual diff of the difference between here and here, and we can see that very quickly, right? We can just look at this and be like, oh, this is all the same, but then this is different and this is different, and it grabs our eye and shows us the important differences between the code, right? Also, if there are any mistakes here where I accidentally put like a 4 and then a 4, or duplicated any of these numbers, it would be a lot easier to spot out when everything is nicely aligned. Okay, let's go through this a little bit more. So we have clock picks to pain picks, and the inputs are at the end and the outputs are at the beginning, which is kind of inverted from the way you usually do it. Usually the convention is output parameters are the last things and the input parameters come before the output parameters. However, we swapped this so that when we're looking at the function signatures of these, we can just swap what's pointers and what's not. So we can keep the exact same order of all these things for this function and say that the beginning things are pointers, and then the other things, well, actually here, let's go and make a little notes file for this. So let's, these are some miscellaneous notes. We could save that in a notes file here. So let's go over here and save this as PAINT5D.n for notes. And this is just an informal file where, you know, when we need notes, we can just kind of like shove stuff in here, right? It's not something that is a requirement of the project. The only requirement of projects is that we have a data file and a functions file, and then everything else is just informal. It's not a requirement. And the reason for that is we can spiral out of controls with the different prefixes we could create and get way too granular. And sometimes we need these outliers, like these things that are pattern breaking once in a while, but we don't want to codify those into our code base because then it just gets out of control. We don't want somebody to remember like a dozen different prefixes or suffixes, right? We just want people to look at this code base and be, there are two things in this code base. There are data files, which is all of the data for a library, and then there are function files, which are all the functions for a library. Nothing more, right? We don't want to like overload people with like a whole bunch of nonsense. So let's take this function definition here for a second. And also, we're going to change that, right? We're going to make this an int16, are we not? Yeah, so we're going to make this an int16. And let's just put this over here for kind of like a reference, right? So, so we could call this function references. All right, we could make a little function references section like this. And then we can kind of paste these in here because I want to show you what I'm talking about. But in order to do that, we're going to have to go from one function to the other function and get both of these signatures on the screen so I can kind of show you exactly what I'm talking about. So we're going to change this to PAINT5D to C2 Glock pix, and that stands for paint pixels converted to global pixels. Now we have this function here, which is the complementary version. We're going to take this, and we're going to paste it down here as well. And we'll put some, we could, you know, we could say, you know, let's just make a comment here. Let's structure this in a way where we can kind of cut and paste it if we want. Or, I don't know, maybe that's a bad idea. Let's not do that. Let's keep this as void. And let's not put the semicolons here. Let's, actually, no, we'll keep the semicolons here because we're going to want to call it, but we'll keep this type here like that. So this is kind of nonsense here, right? Because it's kind of like, it looks kind of like the beginning of a function declaration, but then it also looks like a function call. It's like mixed together, right? But this is just reference, right? It's not actual working code. So, you know, we can do that if that's the way we want to do it. Okay, so now that we have these two functions here on screen, we can kind of show you what we mean about inputs and outputs. So all of the inputs, or all of the parameters for both of these functions, are in the exact same order, and that is by design, right? We wanted to be, the idea was to be ordering everything from general to specific. So you see tile quad, tile exponent, tile layer, local tile x, and then global tile x. And we wanted to keep that exact order in this function and then keep that exact order in this function. However, the inputs and outputs are different, right? Because this is Glock pix to paint pix, and this is the inverted version, paint pix to Glock pix. So to change which parameters were inputs or outputs, you'll see that here these are pointers, but here they're not pointers. Here these are not pointers, but here they are pointers, right? So these are the outputs on this function. These are the variables that make up our conceptual GlockPix object. And over here, these are the objects, or the variables that make up our conceptual PAINTPix object, right? So here's the outputs for this function, and here's the outputs for this function. So you'll wonder what I mean when I say conceptual object. And what I mean like that is there's this code smell of implied object, I think they call it, or variables masquerading as an object, right? Because we're always going to pass together all these variables when we're trying to convert GlockPix to PAINTPix, right? So all these variables technically represent this PAINTPix thing. And so you could say that, oh, well, we should just put these in their own, like, struct or whatever, right? But the problem with that is then I get that these functions are like really unruly and they have like way too many parameters. And like Uncle Bob of Clean Code would say, you know, a function should either take, you know, like 1 or 2, maybe 3 parameters, and then like absolutely no more. And I completely disagree with that. I get that, yeah, you don't want your parameters to spiral out of control. But if that's how many parameters they take, that's how many parameters they take, right? If you have a function that takes a 4-dimensional location and you want parameters x, y, z, and w because it takes 4 dimensions, then you should be able to just call it with those 4 dimensions and not have to wrap it into some type of 4-dimensional struct that has a .x, .y, .z, .w member. The reason for this, like, you'd be like, well, this seems really unruly. Why would you choose to do it this way rather than, why not, you know, why not this way? Why not take this, void, void, and then, you know, struct pointer, or actually no, struct pain.pix pointer, and we could call this pain.pix. We could do pain.pix, so there's a difference there. Why not something like this, like struct pain.pix and then struct glock.pix? So why not this, and then for the other one, something similar. So we got, and the first one here is a pointer, the paint pixels, and the other one is kind of inverted, right? So why not this? Why not do it this way, right? This is the way clean code would kind of tell you to do it, right? And the reason is code readability. Like, I'm going to look at this, and just by reading this, I need some knowledge of what the hell is in here, what the hell is in here. And it makes the code harder to read. Now, you could say, well, you have an IDE where you can kind of inspect the function definition or whatnot. Well, I'm not using an IDE, so no, I don't have that option. And you'd be like, well, why not just use an IDE? And I'm going to say, because we want the code to be as simple as possible and readable. And we don't want the tools to influence us to write worse code. Does that make sense? Where if we have these tools that allow us these awesome abilities of code analyzation, the structure of the code is going to start to suffer because we have advanced code analysis tools. So we want to write things in a way where even the lowest common denominator can understand the code. Where we don't, right? So think about it. When you have a company and you have a whole bunch of programmers, what's the experience level of all your programmers? Are all your programmers top-notch, level A programmers? And the answer is no. And that is always no. And why is that always no? Because even if you hire a rockstar programmer for your company, they're not a rockstar programmer once they enter your company because they need to get familiar with your code base. So it doesn't matter how good they were. Once you hire them, they have to get familiar with the code base. They are not rock stars right now. So if you have, especially if you have churn in your company, you're going to have a lot of people who are novices in the code base. And this kind of style here would be for somebody who is an expert in the code base, somebody who absolutely understands what's in this, absolutely understands what's in this, right? And I don't want to code like this. I want to code, I don't want to expect that everyone is an expert or like a genius. I want to make sure that, you know, even the newbies can kind of grab onto this code, understand what's going on, right? We don't want to be overly clever, right? So that's why we're going to do it this way. Even though this seems kind of very bulky, very unruly, the idea is that it's all there out for us to kind of see. Now, we have all these notes here, right? We have all these notes by the parameters, right? We don't have to, like, go jump to the definition because now we have more room to kind of write out what everything is, right? So that's why we're not going to do this. Now, we could do a little video ID, right? So why not? And then just do at. Well, actually, we can't do comments inside of comments, and eventually this is going to be like a big comment section. So even though this will not be included in any type of compilation unit because it's just notes. I do like to kind of keep a consistent pattern of, let's pretend that, you know, eventually this might be kind of thrown into the comments section of some actual working code for some odd reason. I don't know why we'd do that, but let's kind of pretend and keep that good habit going. And if we're going to keep this kind of habit, we also can't keep these multi-line comments here. So we'll just kind of triple slash those, right? So we can maintain the formatting, but we'll just triple slash all of these comments here. That way you can maintain the formatting, but remove the multi-line comments. Okay, so why are we using these signatures? Let's add a @vidIID and 0070, and the time is 00 hours and 35 minutes and 37 seconds. Okay, cool. And the method below adds extra surface area to the code and hides the actual data we are working with. There is nothing wrong with a code smell of an implied object, right? So there's nothing wrong with an implied object as far as I'm concerned. Like, we do not have to formalize all of the objects in our code, right? If we can, you shouldn't be causing the code to change shape or to change execution paths just because it makes it easier for you to reason about it. You want to make your code simple, but usually you don't want to do that at the cost of actually changing how the code runs. And that's definitely not a clean code way to look at this, because clean code will say, you know, oh, break up all your code into smaller functions so that, you know, you can comprehend what's going on, right? And I'm going to disagree with that. Don't do that. Okay, if you need to call your function from more than one place, then break it up into another function. And even then, if you think you need to call that function from another place, do not put it in another function. Only extract into another function at the point at which you need to call it again from another place. So never break it into another function because you think you might need to use it. Break it into another function at the point at which you are about to use it again. So no earlier than the point at which, oh, I just put another call to the exact same code. Let's break this common code into a common function because now it's called from two places. If we see a function that's being called and it's not being called from at least two places, then we have a problem. The only exception for that might be like some type of like main loop function or an initializer function or something, but little utility functions, those should not be just called from one place. That's just asking for more convoluted, hard to follow code. So that's the way I'm gonna preach this, because that's the way I think things need to be done. And I know that's not the current culture in the industry, but this is the truth. Okay, so we've made some notes, we've ranted a little bit. Let's actually try to fix those tests. So we changed the signatures to both be int16s for the global values, and we made them signed integers because previously they were not signed. And are there any implications to making these values signed that is going to change the logic in here? So let's kind of look at this. And so we have this int16 GTX. So we had a signed integer version of the value because originally we weren't going to use a signed value. And so we have a little bit of cruft in terms of having this extra int16 thing, but I'm not going to change it. And also, even if I changed it, I think part of the design of this function was to never mess around with these pointer values until we're ready to return them at the end of the function, just because it's going to make the logic easier to follow. So yeah, sometimes I do change the execution of the code because it makes it easier to follow. But, so I'm not, like, hard fast on that rule. But in terms of extracting things into other functions just to make the code easier to follow, that seems stupid to me. In fact, I think it just makes the code harder to follow anyways, because you've taken something that was a what do you call it, a linear story or a linear narrative, and you've broken it and you've shoved it in a whole bunch of different places. And you created this web of something that's actually a linear narrative. So you've created extra noise, right? You've added extra complexity or artificial complexity, if that makes sense. So these global values, they look okay. Are we returning these? Are we returning these guys? Hold on, let's make sure these are being returned. So these should be kind of like stored, or we should be dereferencing these at some point and setting them equal to something, correct? And, oh, we see finish this formula. So we've been all over the place. It looks like we kind of like went off to write some unit test code, and now we see finish this formula. So we actually do need to finish this formula. And let's just look at our unit, before we get there, let's look at our unit test code. So we're all over the place, and this is kind of horrible. But this is what we get for having tons of, yeah, we just ended up with a whole bunch of loose ends, and now we're in kind of a bad place here. So yeah, I mean, we got the basic test code stubbed in, and there could be, I mean, I'm absolutely certain that I'm sure there's some mistakes in the test code, maybe some simple syntax mistakes, something that I'm not seeing, and we're not going to worry about that. We know that we have the basic test code kind of here, and we'll expect that if something goes wrong, we're going to get a compiler error, or the test will fail, and this is good enough for me in terms of what's stubbed in here. So these tests here are good. So let's look at our notes here. So we have Glock picks to pain picks, so these are actually done. These tests right here are done. And we need to also add the tests for the get and put functions, right? And for these get and put functions, they're actually going to be altering the data. They're actually going to be altering the data that is in our system. And, sorry. Okay, so in a test-driven development kind of scenario, hey, I see somebody drop by. How's it going? So in a test-driven development scenario, what you would do for test code is you would kind of mock up objects and you would test on the mocks, but that's not how we're going to do it. The reason is that making mocks requires writing the code for the mocks, so that's more time to write the code. You got to reason about it, and even if you try really hard to get those mocks to be like perfect substitutes, they're never as good as the real thing. So what we're going to do instead is, before we run the test, we're going to back up all of the system data in the actual live system that we're going to test. We're going to back it all up. We're going to run our test. We're going to poke and prod at those internals, and then we're going to restore the data. Okay, and what that means is we can test on the actual objects rather than proxy mock objects, and we can test on the real deal. Also, because we're doing this in these tests in a data-oriented design manner, we don't have to think about our mock objects. Well, we don't have mock objects. We don't have to think about what we're testing as these black boxes. When we're testing, we can say, okay, we've done this to the internal state. Let's poke and prod around at the internal state and make sure that it matches what we think it should be. So that's, to me, that means that we can get even more thorough tests, right? Because what if the test gave us the correct values, but the internal state, for whatever reason, was not the internal state we thought it should be? Then that would still be a mistake, in my opinion, right? The idea is we're not just going to test how the data is transformed, like in test-driven development, but we're also going to test our mental model of the internal state of our system. Okay, so let's take a shot at PAINT5D put and get. So you notice here we have like ext vod and whatever, and that's very terse, and that's just to keep our column limit, right? Make sure that these forward declarations don't have to be hard wrapped, and make sure that we don't exceed this column limit here. So if we go up to here, we can see that, you know, ext is just extern, vod is just void, right? So they're just simple keywords. It does kind of like make the code a little bit more obtuse, but the important things that we really need to look for are these things here, right? We have a forward declaration, and then we call it forward declaration, then we call it forward declaration, and call it forward declaration, call it, etc. The reason we're doing this is because usually we don't use forward declarations. Anytime we have a forward declaration, what that means is it means that this function call here is lower down in the file. If we call a function without a forward declaration above it, that means the function is up above in the file, and that is the convention we use. So in general, you want to code without forward declarations, just so that we have an absolute guarantee as to the order of the functions and where to find them in the file. However, unit tests, they usually get out of hand really quickly, and we want to just keep all of our unit test code at the bottom of the file. And you might wonder, well, why not just put your unit test code in another file if it's cluttering up the file, right? And the answer to that is granularity and administrative effort. If something goes wrong with our unit test, what's the next code we want to look at? The next code we want to look at is what we're testing, right? So why not just keep all of that in the same file? And then we can kind of easily Control F through all of the tokens that we want to analyze, and we don't have to like open up another file. It's all right. Everything we want to look at is already right at our fingertips, and that's why we do it this way. The other reason for this is we want to avoid code rot. So we're actually going to kind of like put the tests we're going to try to embed the tests into the code base as much as possible, so it's like really hard to pry those tests out of there. And that's very intentional. The idea is we don't want somebody to have some type of master switch where they can just easily shut off all of the test code. We actually want to make that really hard. And it's a pragmatic approach, because if you heard the thing, there's a saying like there's nothing as permanent as a temporary change, right? So if somebody temporarily shuts off the tests, code rots, we try to turn on the test, there's bugs all over the place, we can't fix the test because it's been too long since the tests were maintained. We don't want that, right? So we don't want that temporary change that ends up permanent. Now, if we do this and we kind of embed the tests in here, we could end up with this horrible thing called a temporary change where you know, we can't get the tests out, right? But I would rather have it very hard to get these tests out of the code in the release mode than to try to get them back in, right? And the idea is that it's going to be a long time before we have a final product, and so we want all of the test code to be kind of like dug in there, right? And we're going to save optimization and getting rid of test code, or like shutting test code off, as a thing that we're going to do once we're ready to have some type of release mode, right? And then even then, when we have that release mode, we're only going to take out the tests on a case-by-case basis. We're not going to implement some type of master switch and be like, oh, we're on release 1, let's add a master switch for all tests. We're not going to do that. We're just going to go case-by-case, remove the test code. The reason for that is the project will still continue to grow after the first release, and we don't want to have implemented some type of master kill switch for the tests that then applies to all of the future tests. Okay, so we got this git test, this click test, and they don't actually exist anymore. So let's see, this is paired unit tests, and I'm going to guess these are just 2 unit tests, right? It's probably the, yeah, okay. So we really should have labeled that section a little bit better, because they're paired unit tests for a very specific case. So, you know, I like that section label. That section label is kind of decent, but I don't know if we should have called it that. We might want to call it, let's just take this and, I don't know, let's just make a little index here. I mean, this is kind of ugly, but let's just make a little index here, and pain pix c2 lockpicks. I'm just going to make a little index. And I don't know if this is... We're making this divider a little bit thicker, but we just want to be able to know, oh, what are the functions we're testing in here, right? And I don't know. I don't know if that's the best way to be looking at this, but that's the way we're going to do this. Hold on. So I kind of meticulously organize things. So we're going to take the same exact kind of thing here, and we're going to move this over. I'm not sure exactly where it should be moved over, because we got these, like, colons. I guess it looks like it kind of makes sense over here, like that. And then we'll kind of, like, put that same kind of pattern in there, right? And a lot of people say the visuals of the code do not matter, and I highly disagree with that, because the way your eye flows over the code will help you be able to look at the code and be like, that looks wrong, right? And to say that looks wrong takes a lot less mental processing power than logically parsing the code and doing math in your head and all that stuff. And that's good as well, but we want to reduce the amount of mental effort required to find mistakes in the code. And to reduce the mental effort to find mistakes in the code, aligning everything nicely will do that. And you'll be like, well, what's the point of reducing mental effort? Shouldn't we think? Well, yeah, we should think, but we only have so much thinking power. So if we have, say, 100 units of thinking power, but it takes 100 units of thinking power to find one mistake because we haven't meticulously organized our code, then we can only find one mistake with that 100 units. If we structure our code in a way where we can visually see what's going on and visually find mistakes quickly, then we could reduce the mental thinking power. Now we could say that instead of taking 100 units of thinking power to find a mistake, it only takes one, right? And then we can find 100 mistakes rather than one with the same amount of mental power, right? And everyone has a limited amount of mental power in a day. Okay, so we have this kind of section, right, of unit tests, of all the unit tests we're going to use, and we need to make, like, another section of paired unit tests. So I did like the kind of, like, calling things paired unit tests. I'm going to call this, like, get put tests, or main get put tests. And I don't know why I kind of use these dashes like that. I'm not going to do that over here in this section. Alright, so we have a little section. The way I write this is, right, we know the top of the section is here because this is left justified, the bottom of the section is right justified. So that way, when we see a comment, we know when the comment applies and when the comment stops applying, right? And a lot of times when you write comments above code, you know when the comment starts to apply, but you don't know, like, how far that commentary sinks into the remainder of the code. This gives us a way to know how far the commentary sinks into the code without having to think about it too hard. Okay, so these tests here, let's actually write the signatures now. So we're going to do void, test name, and void. Right? They're not actually going to return anything. And then we want a little divider between the put test and the get test. Dash line I2 maybe. We want a little divider between the tests, and then we'll do the get test. So we're going to do the put test first and then the get test. We've kind of decided that in ordering, put should come before get, because you can't really use a get if nothing was ever put. But you can always put something somewhere, right? So if there's nothing there and you put something there, that's a valid operation. If you try to get something but nothing has been put, that doesn't make sense. So we decided the ordering, when we're trying to think of when should we write put, when should we write get, we're going to say this is the ordering, this and then this. So if we wrote it like this, if we wrote our code like this would be improper. You might say, well, it doesn't matter, it's still going to compile no matter what, but the idea is that we want stricter ordering constraints than what the code tells us to do. Because the stricter we are, the less problems we'll have. Okay, so we have these get put tests. What do we want to do for them, right? What is the, well, first of all, what's the signature for these tests? So we have, like, this is, These are coordinate conversion functions. Alright, so these are coordinate conversions. And let's kind of label those as coordinate conversions. So let's take this section, and we might have to indent a little bit more. Or we'll see. Actually, no, we don't really have to, because look, we can use a line hierarchy to kind of avoid that a bit, I think. Well, I don't know. Let me think about it. Coordinate conversions. Well, we could take this why not and kind of indent that a little bit. And then we can scooch this over a bit like this, and then we can get rid of this extra spacing here. So the idea is we want our documentation to all be very clean, very nice looking. So in an aspect of clean code, there is one thing that I like to be clean. It's just very clean, organized, methodical structure to the code, which is interestingly not clean code. Isn't that interesting that that's not clean code, what I'm doing? What I'm doing right here is not clean code, but you'll see that everything's like clean and methodical and visually very rigidly organized, yet it's not clean code. It's like, I don't understand. Okay, so coordinate conversions, and we need something else in this function reference section. Let's just put it at the top of the file. And the next thing is what are these? So it's a get and a put. It's really the main functionality, or is it the main functionality? It's the main data interface, I guess you could call it. Yeah, let's just call it main data interface. That's a really weird thing to call it, but that's kind of... It's the main data interface. That's really what it is. That's like a really weird thing to call it, but I mean, that's really what it is. It's not really a conversion function. It's more like a interface for how we're kind of interacting with the data and abstracting the data and packing it onto the texture, right? So in here, what we're going to do is we're just going to take those signatures that we want to test and find them, right? So we can do... We look for AAC 2020, and actually it's all uppercase because this is a public function. 2020 PAINT5D put. If you look for that function, we should be able to find it. And there we go. So we see the signature, and it looks like this has not been done yet. So let's just kind of introduce some compiler errors to the code, because we have a lot of loose ends, and I don't actually want to have to come back to these loose ends like at a later date. Like we have this to-do manager thing, and sometimes you can put like a vital to-do to be like, you know, hey, come on, fix this. And that's good as well, but we're actually going to introduce compilation errors until we have actually addressed every single section of the code, because we have these loose ends like all over the place, and we absolutely don't want to miss any of them. And also, to make sure we don't miss any of them, we're going to do a little other thing here. We're going to add the to-do manager here, and we're going to do a vital to-do, and we're going to say, you know, finish this, right? Finish this code. And it's 2020 12/31. And it's 7:10 p.m. And we're kind of out of room here if we do this. So finish, instead of saying finish this code, we'll say finish code. And this is just a unique message that we can kind of find in the code. And then same thing here. We're going to say paste this here. And then we can just call this one, we could call this get. And we could call this one over here, we could call this put. Right? Because those are the, now we're still out of room. So, let's just call it finish, the date, the time, put, finish, the date, the time, and put, right? Or get, right? So now we have two unique error messages that will not conflict with any other error messages in our code base. We're introducing, this is very dirty, but it's pragmatic, right? So a lot of things we do are really dirty are also pragmatic, right? We're just going to introduce a compiler error here, introduce a compiler error here to make absolutely sure we don't forget about implementing these functions. So you'll notice that right now it looks like I'm about to write the test code first rather than the function first. And I'm not against writing the test code first. It's just I'm against a rigidity saying you have to always write the test first or you always have to write the backend first. You should write whatever code takes the least mental path of resistance to write at that point in time. Like if you already have all the variables loaded in your head to write the back end, then go for the back end. If the mental space you have loaded into your head is all the stuff for the front end interface, then write the front end interface. Write whatever is already loaded in your head, because there's a penalty for context switching, right? Right? When we talk about Scrum, there's a context switch penalty. So we shouldn't enforce this rigid rule of always write the test first when there's going to be that efficiency context switching kind of penalty to switching over to something that's not currently in your headspace, right? Because you got to forget about everything that was already in your head, and you got to load all these other variables. And we're not like computers. We can't just load up a whole bunch of stuff into RAM like instantly like that. It actually takes a little bit of time to absorb things and get into the correct headspace. Okay. So we see the put and the get functions, so we're just going to take them, and we're going to just paste the put. Remember, put comes before get. We're just going to paste them here for reference. And this is a little bit like, this is a bit much. Now let's keep it like this, and then do this, right? So it's not quite a function. Is this a proper prototype? Yeah, I guess this is kind of a proper prototype. We're just using this for reference, so the actual syntax here doesn't matter. We want the syntax to be close enough to the end syntax when we call the function, so it takes minimal editing. But really, these are just pasted here for reference, so that we can kind of see the complementary functions right next to each other. You can see those complementary signatures right next to each other. Now, this might be something that other people would use what's called a header file for, where you put like the function prototypes all in one file, so you can see the big list of all of it. But we're just putting this in an informal notes file, because we're not going to do that way. We want to have a very strict function ordering, and function prototypes will actually wreck that for us. Function prototypes will allow us to put functions in any order, and we don't want that. We want a more strict ordering. Okay. Yeah, let's not worry about indenting this anymore, because I do feel like this really should be indented more. Well, let's see. If we indent this more, what do we actually have to clean up? It looks like we have these other things right here, so we could actually... There we go. We can just do that. We haven't really lost anything. What about this? Can we kind of fix this? We could probably call this subquad, right? If we call these quad... And let's just indent this, right? If we indent this like this, what could we change here? So tile size enum, tile exponent. It's really a tile size. How about tile size exponent enum, right? Which is kind of a mouthful, but then it doesn't overflow. And local tile x chord slash bx. I could probably make room for that. There we go. So now everything kind of nicely fits in there with the indentation pattern that we like to use, right? Because we want more indentation rather than less, as long as it has some type of lexical meaning, right? So this is indented because it applies to this section header, right? So yeah, we could take this right here, and we could kind of clean this up here, and then we just gotta kind of subtract this over here. Okay, cool. So that looks good. And let's not worry about writing these functions right now. Let's actually go back to the test code that we were writing and start writing a test table and figure out, well, what needs to be in the test table. Well, I see one of these things is a pointer. So put, okay, I see. So we're putting this value right here. So it's the exact same signature, right? Well, not the exact same signature, right? Because this is a pointer here, but this is not a pointer. And this is void, and this is not void. So the getter, we want the getter to be void, because we don't want any confusion about how to get the data back, right? And if we have a return value here, then it would be a... I wouldn't blame anyone if this had a return type of UO8 to think that calling this getter it returns the value, right? But it doesn't return the value like that. It returns it via a reference here. So to avoid any accidental confusion, this absolutely needs to be void. Okay, with that done, let's think about this. 1, 2, 3, 4, 5, 6, 7. So we have 7 pieces of data. The quadrant for what auto tile subtile we're looking at. The tile exponent, which locates how big is the current tile that is being set in the design. The layer, telling us are we on layer 0, 1, or 2, right? Which of the 3 layers are we designing on? What's the actual local X and local Y of the current tile? And then, on top of that, we have this thing called the offset dex, or the auto tile set index. And if we look at our data partitioning, if we look at PAINT5D.d, we've decided that we're going to take these 32 bits and we're only going to use 2-bit color for everything. And what that's going to allow us to do is for every physical position of data, we can split that up into 16 sections and say that we have 16 unique data sets, right? So, because how we're going to partition these 32 bits is into 16 clusters. And then for this data set here, this is the layout of the pixels, we can say that we have 16 of these. And the reason for 16 of them is because 16 tile types seems like it's not too much to work with for materials for the game I'm working on, but it's not too many. And we have to find a good balance because we have to remember that the artist has to create all that data, right? You can't be like, oh yeah, this thing is going to have like 1 million different textures, right? Or it's going to have 1 million different playable characters, right? I'm obviously being kind of absurd here, but the idea is, right, the more assets that you say need to be made, well, that's more work for the artist. So you need to find a good balance there. So we're actually going to design the engine in mind for how much work does the artist actually have to do to get something decent ready. Okay, so we got these gets, we got these puts, we've kind of ranted about it. Let's get a test table going. So what do we want to do for this? Do we want... So once again, we have these 4 basic quadrants. So let's keep the tests very similar to the other tests we did. And in fact, let's see if it's possible to take kind of like this kind of code that we already wrote and let's see if we can take it and actually make sure these vitals don't match. Okay, yeah, they're different. Yeah, let's take the test code for here because it's going to have a very similar structure. And let's try to rework that into, yeah, let's just try to rework it, right? So let's take this right here. I'm going to just take it all. The whole body of this. Copy that. Make sure we got the whole body. There's nothing wrong with cutting and pasting if it's going to, right? So the idea is that, you know, a lot of people say, well, when was typing ever the bottleneck in your development cycle? And yeah, a lot of times it's not, but to say that it's never the bottleneck is totally not true. So we'll call this 7:20 p.m. Make sure this is a unique kind of token. I just care that it's a unique token. And the next thing we want to do is we want to go through this code, and we want to strip out any of these video ID comments, right? Because we're about to kind of rework this, right? We cut it and pasted it, and we're about to rework it. So anything that's a video commentary ID is no longer valid. So we need to just strip all of that video commentary out. So we could say this is we'll just here's what we're gonna do for this. We're gonna go 0070, and the time for this is just question mark, right? Because I think we'll eventually get to making a commentary about what these are, because I think it might be important, and I think we're going to have this very similar structure here. And we're at video 70 right now, so we can kind of say we're at video 70, but the time we don't know yet. This video ID thing, we can kind of strip this out, or we could look at variables for iterating through test cases. So actually, that commentary is still the same. So let's keep this, and let's take the timestamp. So it is 1 hour, 9 minutes, and 50 seconds. Okay. Now we can kind of do this. Okay. So variables for iterating through test cases. So we're talking about TI, BAS, and MI. So max index, the test row index, and the base offset for the test data. This right here needs to be changed because we can see this is a macro for, it's not obviously a macro because it's not all capital, but we kind of named it like this so that it matches the function that it applies to directly. But we want to change this to something else. This should be something like, well, first of all, let's copy this everywhere and see where these need to be changed. So these all need to be changed. And right now, it's really just PAINT5D put. It's actually put cases and get cases, right? So, how about num test cases put? We'll call it num test cases put, right? So num test cases put. And anywhere we see the number of test cases, we're going to change that. And then also where we see datum, so let's kind of paste this up here really quick. Anywhere we see datum, it's going to be the same thing, but it's going to be it's going to be columns per row, or num test columns. That's really what it is, right? Num test columns. I'm gonna just do write columns like that because I just don't wanna. I would like it to align. So we'll just do it like that. And then this thing right here, this is the number of test columns. Okay, cool. Then over here, we can kind of do this, and let's do the number of test cases is going to be 4. But as far as the number of test columns, I actually don't know what that value needs to be yet. I know this is going to be 4, because we're just going to put 4 test cases and not get too intense with this. Right? We just want to stub in a working test runner and then kind of forget about it for a while. But right now, I don't know what the number of columns is going to be. Columns. Okay, these are columns. Right, we'll make a note about that, and then we can also put a little checksum here of, you know, what macro is, right? We want to make sure that we keep track of these macros, right? Because we have macros all over the place. We like to keep our macros all locally defined to a section. So not necessarily a function, not necessarily a scope, like a lexical scope like one of these, but to a function, right? Or not to a function, to a section, right? So we've had this commentary to create a section. And even though it's just a comment, we treat our comments as if they have some type of syntactical consequence on how we need to write the code, right? We want to be very rigid in our style. So down here, this is the end of the main get put tests, and I noticed that, is that the correct? Did we label that correctly, or are we missing something? So main get put tests. So if we look up here, okay, nope, that's the same exact label. I just wanted to make sure. I thought we might have had something like this, where we had this, and then we had some type of sub-label, but we don't, so that's fine. Okay, so let's work on this. Before we work on this get test here, before we work on this one, we just want to make sure that we've kind of fleshed this out, right? Because we cut it and pasted, and now everything is going to be slightly different. So let's think about what data we have. We have the qua, we have the exponent, we have the layer, and we have the location for the tx and ty. But instead of having a global we have the osdex and the val. So, oh wow, I noticed I did this kind of backwards. Oh, I see why we did that. So let's take the most important thing. So os kind of seems like the most important. So over here, the most important component of this variable name is probably os more than it is dex. So we're gonna say this is os, right? That's the os dex. Now for this tile, we use tile all over the place. So the value, underscore value, is probably the most important part. So now I can kind of see why these underscores are kind of on different sides. It's because we were kind of picking and choosing what the most important piece of information was when we were kind of sectioning out this test table. So we actually have the exact same number of data points as the other test, right? It's just that what the data represents is slightly different. So the number of test columns is 7. That is the answer. So now we know what the answer to that is, so that's cool. We're making some progress here. Okay. So now that we know we got this 4, 7, 4, 7, obviously we've written this word in a completely crazy abbreviation way. I do not expect anyone to ever remember, what that means, right? The idea is that you look at it, you see this as columns, and then that should be enough to kind of remind you, oh yeah, this is columns, right? But I don't want anyone to actually remember like how that's spelled or whatnot. It's just a completely ugly abbreviation just to make everything lined up nicely. So that is kind of like, I do some things in very weird ways that, but I'll explain why I do things the way I do them, and you may hate them, right? Okay, so for the data, we got to think about, well, what's the inputs and what are the outputs? Well, this is the put function, so we're looking at this function here. And the put function does not actually... what do you call it? So we really need like a get put function as well. But the put function doesn't... We actually need to use the get function to test what was actually put, right? So these individual get put tests, these first two are going to be kind of spot checks, where we're going to test very specific cases, and then we're going to do one massive test where we test literally every single point and make sure that every single point converts correctly, right? Or we're going to pair the get and puts together. So we should probably, while that's still in our mind, we should probably do that. So we have a put test, then down here we have a get test, and then we need the final mother of all tests. That's going to be void AAC 2020 PAINT5D. Unit test code, and we're going to call it, we should call it put get, right? Because you cannot get before putting, right? Because we're going to put stuff down, and then we're going to get it, and we're going to just make sure that what we put matches what we got, right? So put get is what we're going to call it. We can call it put get like that. I think that's fine. And then also we might want to do something like this. Since we have this, we might want to make a note of the complementary thing and just say that that's not a thing, right? So if we take this and do the inverted version of get and then put. All right, we want to make a note of what we do, but we also want to make a note of what we don't do, right? The whole idea of like you don't see the bottom of an iceberg. We want to kind of make that bottom of the iceberg visible. Right? The analogy of like you only see like the 10% of the effort, you don't see all that other effort, right? Well, we actually want to make that other effort kind of obvious. So we want to make it, we want the code that is not written to somehow be visible, and this is how we're going to do it. So if somebody tries to do this, we're going to say error, there is only put get, never. So let's put a commentary above this, because this is still kind of cryptic. So take the video ID of 70, and take the current time of 1 hour, 19 minutes and 32 seconds. And we're just going to say that make note of what is not done so that no one comes along later and adds this function. Right? I just want to make a note of, hey, there's a reason we don't have this function, right? If we don't have this function anywhere, then somebody could be like, oh, we have a put get, but we don't have a get put. We should probably have a get put, right? But there's a reason why we don't have a get put, because we cannot get what was never put, right? That's the whole reason why we don't have this function here, right? We cannot get what was never put. But it's still good to just have it here for reference, so it never accidentally gets put here. We want to know why we did not do something, as well as know why we did something. And a lot of times in code, you always see why something was done, but a lot of times you don't see why something was not done. And we want to make that a little bit more friendly. So over here, we're gonna just do this, and this is test all the values on the 512 by 512 bitmap. Right, that's what we're doing here. We're going to test every single value. And how are we going to do that? Let's just make a note of how we're going to do this really quick. We're not going to write all the code, but in order to do this properly, to make absolutely sure we're kind of doing everything, we're going to do like a for loop. And we're going to do like pixel x equals 0, and then pixel x is less than or equal to 512 minus 1, and then pixel x plus plus, like this. Okay, and then the same thing for the, oh, hey, sorry, oh yeah, I just, I looked up and then I like see it just pop out of nowhere. Hold on, let's put the little, little chat box thing up here for a second. And then, so unfortunately it takes a while. I gotta like type some gibberish in here. Like that. Okay, there, now, so I didn't do a very good job with that chat box. I need to kind of seed it, but, like that. But, now whatever you say will show up, in the chat box there. So how's, your, New Year's going? I thought the best way to do, New Year's was to actually, you know, actually do something productive and useful. Start off the year on the right foot, as far as I'm concerned. But yeah, I'm just writing some test code. I still have a whole bunch of loose ends, but I'm kind of writing test code. I'm not writing all of the test code. Like, I'm writing the test functions and writing a few test cases, but I'm not writing all of the test cases. So the idea is just to get everything kind of stubbed in there and get everything working, and then I'm going to add some more test code. That's the way to do it. Yeah. I hope this is the way to do it, because, you know, sometimes I question myself as whether I'm sane or not, when I'm writing code. But yeah, but yeah, we're just trying to, and also we're doing some really batshit crazy stuff. Like, since we have so many loose ends, I'm just like, here, just like scribble some random stuff here to make absolutely sure this stuff does not compile until we, you know, address this function, right? Like, don't compile, this is me saying, don't compile, don't forget about this, right? So I am doing kind of weird things like that, and then also, in addition to that, right, we can also do like to be extra cautious, I can take my to-do manager, so I can do AAC 2020 to-do manager. So this is my to-do manager, and I can make a vital to-do, and I can say, you know, finish this code, right? Right, just blah, 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 like that. And then that way, we see this, it doesn't compile, we add some code to it, but maybe it's not completely finished. So we have this vital to-do, which if it's still here, that means we got to look at the code again, make sure that all of the test cases we want are actually there. If they're all there, then we finally remove this kind of message here. And this message will only crash the system unless when I turn on my vital to-do macro. So I've gone over this before. I don't know if you've seen it before, but in this library, in the main like build kind of file, where we have the high-level overview, we have this thing called crash on vital to do. If this is set to 1, then this command will crash the program at runtime. Otherwise, it'll just echo a little message saying, hey, you need to write some code, but it won't actually crash. Same thing with maybe to do. Maybe to do is things that, maybe I want to do them, but they're like feature creep kind of things where they're not necessary. And I can also crash on maybe to do. So the general idea is if we've actually done all of the vital to-dos and we have no clue where we want to go, then we'll crash on the maybe to-dos and kind of address those as well. So, but right now, it's just about getting this stuff up and running. And also, I did we're going to advertise as PRC as Hirosa has, I don't know if I'm pronouncing his name correctly. I know his name's like Henry or something, but his handle is like Hirosa. But yeah, we're gonna go with a PRC thing. We're gonna push that as a marketing kind of thing. Okay, so anyways, UTC get, okay, we're over here, and we're just kind of fleshing out what this test code needs to look like. If we're going to test every single value on that bitmap, then we need to do a loop through every single pixel, and after we've looped through every single pixel, we need to, yeah, there we go. Yep, put a little trademark in there. Technically, I wanted to, like, do, like, be kind of, like, silly like this and do, like, be kind of silly and do that, but I'm like, technically, if we want to be, like, if we want to go by the book, technically it's not legal to do that, to do, like, a reg TM, so technically you're violating the law if you use the registered trademark symbol and it's not actually a registered trademark. So so the only reason there's not a registered symbol there is because I'm like, man, I'm gonna I don't want to end up, violating federal laws. So it's like, so even though I would be using that in jest, I'm like, oh, let's be careful here, because the feds do not have a sense of humor. Case in point, Aaron Schwartz. I'm sure there's other cases, but that's the only case I can think of, right? Where, like, hackers just do something silly, and sometimes they're like, hey, look, your system has this vital problem with it, but we left you a little note on your desktop, and then they go after you for hacking into their computer system when you're just trying to be nice and warn them about a system vulnerability, right? So, so it's like, yeah, I don't know. It's like, I don't know, whatever. Okay, so we're going to loop through each one of these to make sure we can cover every single pixel. And we want to, this test is actually going to come after the conversion tests. So we're already certain that our conversion code, like this conversion code, is correct. And because we know this is correct, technically this PX, PY thing, these are actually our global values. So we can take this functionality right here, right? We don't have to redo this, right? Because we already have these tests that say that code is right. And those tests run before that. So we can kind of throw this in here. And this commentary is like, okay, this commentary is going off the screen, so we got to think, well, what kind of matters here? Offset tile, subtile quad. How about offset subquad? That kind of makes sense. This is actually just the size exponent, you could say. So we're trying to summarize things. As we run out of column space, it actually forces us to be kind of more terse and get to the point. So local tile X, local tile Y, well, do we really have to say that they're coordinates? And I don't think we do, because I think that part is implied. Now BX, BY kind of applies when we're using the editor as a brush. So I see we got like a second person in here. So I'm gonna just drop my kind of demos in here, because I don't know who's looking at this. But let's just throw in the demos, my like technical demos of all of the things that I'm trying to merge together into this final engine. So all the technical demos you see there, or most of the technical demos you see there, are proofs of concepts that are little pieces of what I want to put into this final engine design. And then also, let's look at some little GIFs really quick. Also, before New Year's, we actually might want to take a break and actually play the game for a little bit, because I don't know if Chrome has like some type of kill switch for Flash that's going to activate on New Year's. So let's actually like throw in some syntax errors here, and let's take a break to kind of play the game on Newgrounds for a second. Because so on so kind of like well, actually, could we use can we just use can we use Torch? Will Torch work? Let's go to Newgrounds. So I don't know if Torch supports Flash, so we're gonna find out. So let's go search for Atomic Alice for a second. Let's search for the old game and see if we can play it on Torch, or if we got to use Chrome. And we're gonna like take some screenshots or whatever, full screen this, right? Play it. Just have something that we can click to enable Adobe Flash Player. Now, Torch is a Chromium-based browser, so that makes me think that eventually this will not be something we can use eventually, because what am I trying to say here? If Chrome stops supporting Flash, then because Torch is Chromium based, Torch thus will also, by inheritance, also stop supporting Flash. That's just my assumption. I don't know if that's correct. So we got this thing here. Let's actually, before we start playing it, well, let's just go 2nd, 3rd, and 9th. Okay, so here's our little preloader screen. And we can kind of click these things, destroy them. We can lay more little things right here like this. But I'm going to get something together so we can kind of full screen this nicely. Well, actually, we got to go over here before we can do this. So the password here is beta12, so we never actually finished this. Let me turn off my shortcuts, suspend hotkeys. So beta12. Okay. So once we're in like the full screen mode, we're going to turn this down. Okay, now that we're here, we can go to full screen. And once I'm in full screen, I want to kind of recrop the screen so I can see, so I can get the whole gameplay area. I don't care about this UI part, but you can see it's not quite cropped. So I'm going to do some editing with OBS really quick and make a new scene for this. And I'm going to call this like Newgrounds full screen or whatever. So expect the transmission to kind of go black for a little bit as I kind of get this working. So hold with me, please hold. And we're going to call this, I'm going to call this NG full screen. Okay, I'll be right back. Okay, so hopefully you can hear me now. I'm going to add the input capture for the display. So display capture, and we're going to do a new display capture, ng full bot, and that's the screen we want. And actually it's full screen already, so actually we could just take that and work with that. That actually works fine. So yeah, there, we got a full screen and we're ready to go. So let's I'm gonna keep the sound off just because it's not it'll get annoying after a while. Unless we want to kind of like turn up the sound just a little bit. We could turn up the sound just a little bit so we have a little bit of noise, but not too much. Too much. Okay, that's good enough. So just kind of light sound here. And let's full screen this. And allow. And yeah, because it's New Year's and I don't know what's going to happen, so let's try to play through all. Let's take a big break, try to play through all this. And let's add audio input, audio output capture, and it's HDMI-C. Okay, cool. So yeah, let's take a look at this. So, you see this piston coming down? Well, that destroys these glass panels, and then it eventually falls into these bombs, and when anything heavy hits the bomb immediately explodes, right? And we have these, like, chain reactions, right? So with Bomberman, usually all the bombs that are connected will go off all at once, but that doesn't make it possible to have these nice little chain reactions. So by adding a little bit of a delay before a bomb hit by a flame or something explodes, we can create these chain reactions. Also, bombs are kind of like proximity mines in this game. But here we have these little switches you can hit, and these switches emit sparks, and if a spark hits the bomb immediately explode. So we can kind of do this. Okay. When the level is destroyed, you can see sometimes when something breaks, it kind of leaves behind a scaffolding that you could actually climb. Like, this part of the scaffolding you could climb. It's like a ladder kind of pattern, and I don't know why it keeps on telling me that. Okay, so let's keep on going here. We made a lighting system, so if we break all of the lights in a given level, the level will turn black. So if we hit all these things here, boom, turns black, looks kind of cool, right? Okay, so right here, what we have is we have these bombs right here, and this blue material is an indestructible material that allows flames to pass through it. So the explosions from here are going to be able to open up and shatter these light fixtures so that you can get to the exit. And so we're going to hit this piston, it's going to explode all of these, and then it's going to make this open up. So we're going to do that. Boom, right? And then you can get to the exit, right? So let's just refresh that, do it one more time. Let's just do it a few more times. Let's do it 3 times, right? So, bam, right? And then let's do it one more time. Bam, right? Okay, 3 times is a charm, right? So this level, designed to teach you to go up and down through here. And either way you do this level, you always have to go both up and down. So if I hit this thing on the top, it's going to shatter the bottom, right? And now I have to get to the bottom to go to the exit. Now if we reset this and do the opposite, right, and go down to the bottom here, woo, down to the bottom, explodes up here, it opens up here, so now I have to go through the top. So either way I do this, I have to both traverse up and down. So I usually like to do it this way, because then after I go to the top, I can just kind of like go, ooh, just fall right through, like that. Exit. Okay, so this, there's not really, I don't even know why. Oh yeah, so once you break a light, I think the lighting mode can change. I think that's why I have this little piston right here. But anyways, proximity mines, all the bombs are proximity mines, except for these skulls, which are instant kill. And proximity mines have a delay, so we can kind of run through them and trip them, and then there's a delay before they explode. So you're going to see this section right here kind of explode, and you'll see there's a little indicator when you're near a bomb that kind of tells you the direction that it's going to explode in. So these kind of snowflake bombs are horizontal. So let's kind of go through here, and now we're just going to try to make it out alive, right? So let's try to do that one more time, though. Let's die. Let's try to do everything kind of 3 times for good measure, right? So let's explode this one more time. You're going to see this bridge kind of explode, right? And then it's going to kill me, right? Oh yeah, I'm going to fall. Okay, so one more time, let's actually beat the level now. So you saw it kind of chain react a few times, right? Okay. So over here, we have little crates where AI sometimes comes out of. This AI, I believe, is going to run straight towards these bombs and kind of demonstrate that these bombs, you shouldn't touch them, right? So the idea is that before we allow the user to interact with these bombs, we want to hopefully have a way where they can tell that these are dangerous, that you can't touch these, but you can touch these, right? So if you touch these are going to kill you, but you have to go one way or the other, right? So this AI demonstrates, oh, that's dangerous, right? But then we have to we can either not learn from the mistake, and we can go this way and die, or we could, I think we could also do this, right? We can also do this. Oh, wait, hold on, let me try that. I'm not sure why I put that in the design, but maybe it is helpful. Well, so let's see what happens when we do this. So it's just a little shortcut, I guess, because this way is a little bit longer, right? Because now you have to dodge all of this, I guess, maybe? I don't know. But let's try to, like, beat this. Or not. Okay, let's actually try to do this, so... but we don't want to beat it the first time anyways, because we want to kind of demonstrate what's happening here. So right now, these vertical bombs can kind of take out the... Oh god. Take out the floor, right? So the idea is... we want to have different ways to apply pressure to the player to, like, keep them going, right? Sometimes the level design is designed to make you think. Other times the level design is just designed to apply pressure to the player. Right, so let's do that one more time. Let's actually do that 2 times. Right, so we want to repeat everything like 3 times, because this is New Year's, so once this is no longer a thing, then I don't want to have it to be a pain to get back to showing footage of this. So we want to make a nice long kind of video of this kind of stuff here. So let's look at what else we got here. Okay, so we got all these levels, right? Let's just go through this ABC thing. There's different level sets here for this, right? The idea was to... There's actually a Metroidvania type system in this game, but we don't often implement it. But this is an up thing, so this makes the levels harder. This makes the levels easier. And this keeps the levels the same level of difficulty. So if we want to get to the difficult levels, it's obviously a more difficult path. If we want to get to the same difficulty, we just jump down here. And if we're just completely lazy, we just take the easiest option. So let's just take the easiest option, because I don't think I did that. And then we can try to take the other paths. So here we are, easiest option. And everything, it's almost like this option is almost like a little tech demo, right? Where it's so easy, it's kind of insulting. And, right, so we can't go down there because we would die, but now we can open that up. Let's reset that. So let's say that we didn't know what we were doing, and we thought we could touch all the bombs for some reason, right? So, we just go like this and go BAM, right? So let's actually do this the right way now. Okay. So this one, I don't know why this is in the easy, because... This is not the easiest, Okay, here, let's take our sweet time here. Oh, actually, we gotta touch these. I'm pretty sure we have to touch these pistons. Yeah, because these pistons are what, cause those instant kills on the bottom to go away. So actually, let's do it without doing the pistons, so I can kind of show you what that looks like. So, let's say we don't touch the pistons at all, right? We just try to dodge, dodge, dodge. And we think we're doing a great job, right? But we haven't touched any of these pistons, so then when we get down here, instant kill, bam, dead. So in order to get through here, we're going to have to hit this piston, jump over the flames, jump over the flames again, hit this piston to get rid of those other instant kill bombs, jump over more stuff, hide over here, wait for it to come to us, boom. I don't know why that's the easy level. That's not really an easy level. So the interesting thing is, because since the explosions for the small bombs are a very small radius, these don't chain react, right? And that creates like a little minefield where you just cannot go back to a certain point you've touched recently, right? So the way to solve this, I think, is just go down here like this, kind of hit this, kind of run up, and then kind of do that, right? And then, I don't know what this is all about. Just a death trap, just for the fun of it, it looks like. So let's just do this one more time. We want to just kind of demonstrate everything more than once. And I think twice will be fine for this level. Right? So let's say we're stupid, right? And we just kind of stayed here for no reason. Then... right, you're dead, right? Now, obviously, you're probably not going to make that mistake, but, you know, if you were to, then there you go, right? Now, hold on. So why is there this switch down there? Oh, does that switch open something? Hold on, let me reset this for a second. So what is this switch all about? I don't know what this switch is all about. Why is there a switch there? What happens if we... Okay, so let's not hit this switch down here. What happens if we forget about that switch? Is there some type of consequence for not hitting that switch? Okay, so we're down here. Oh, I see the consequence. So the consequence is we can't get through here, right? So if we don't hit that switch, then we're dead, right? Okay, so I see. So I just want to make sure that the level, that I understood why we had that little switch there. And there is a very intentional reason for why that switch is there, right? Okay, so this level, if we hit these shards, boom, right? Isn't that fun? So let's do that again. Right? And if we kind of like... Okay, one more time, because that's kind of entertaining. Right, so you can hit the light fixtures with your head. Now, why do I have all these guys, all these little AI? Oh god, oh, so these AIs, they kind of light bombs. And I think that depending on how they explode things, they might be able to soft lock you in here. I don't know. I probably tried to design to make sure that wasn't possible, but I don't know if it could be possible. So this, I don't know why. There's just an exit here. So what's the point of that? And then there's this guy right here, and there's that thing. This doesn't look safe. Like, why are we gonna... Oh, I see. We can choose the evil path and kill all these people there, right? Oh, God. Yeah, so we just kind of destroyed all those people, and now we can go to the exit. Or we could kind of... I want to watch this guy kind of nuke things down there. Very cool. Okay, so let's reset this. And, right, instead of doing that, we can just go to the exit. Or we could, you know, we could let this guy out. And, I don't think he's gonna... Does he touch the button? Actually, I believe he can touch the button. I don't think he is necessarily designed to go after the button. But he might. Oh, there, and he blew himself up. Okay. So, let's try the other level set. So, we tried these Metroidvania kind of thing here. And we know that if we go up, we can get to the hard levels. So let's kind of try to keep on playing this until... Okay, so we can't get to the hard levels once we get down here, right? So let's just kind of die and try to get to that hard section, right? Because up there is where the hard stuff is. Let's... Oh, and... Right, so our head can kind of damage those. So it's actually... That is intentional to make it kind of infuriatingly difficult to get up here. Okay, we're going to have to, like, have our button on the reset here. And that doesn't make me very confident about what's going to be up here, right? Oh, what the... So this is infuriating. Like, I do not like this design, where it's like, why are you making this so hard? Okay, so we're up at the bottom, at the top, and, okay, we have an instant kill thingy, and who's this guy? Is this guy he's a suicidal guy, I guess. That's cool. Let's reset that, right? Let's try to play everything kind of more than once. There he goes. Fun times. Reset. See him go. There he goes. Okay. So, instant kill. Oh, God. Didn't see that. Okay, so this is just a run for your life kind of a thing. Yeah? And if we don't make it fast enough, like if we didn't make it here, we get caught, right? Now, obviously, I'm just kind of exaggerating that because I can actually... I'm actually good enough at this game, but let's pretend that I was not good enough at this game, and, you know, I got caught, right? That's obviously convoluted, right? Well, let's... But if you're new to this game, this part is actually kind of, like, intense, where it's like, oh god, oh god, oh god, but I'm actually kind of skilled enough at the controls where it's not... except for that part, oh god. Okay, let's try to not die. So this is actually pretty hard. Okay, so the key here is... Okay, I'm just gonna... Okay, there we go. So down here, some stuff explodes, some stuff... So this little AI guy drops out. And he's actually not... I think he lights bombs, yeah. So let's just, yeah, wait for him to go. Let's reset that. Let's run that 2 more times. Alright, and there he is. Right, and one more time. Well, we have two little vendetta guys. And I don't think there's any way... The only way you could actually kill this guy, since you don't have bombs of your own, is you would have to... You'd have to, like, get him to kind of fall into his own bombs. So, like... Oh! Let's try that. Let's try to actually get him to... There we go. Bam! He's dead. So, this guy, suicidal? Yep, he's a suicidal guy. Let's reset that. So, Newgrounds, I actually do use Newgrounds. Let's reset that one more time. Okay. Alright, so we did the hard levels. Let's try the, medium. So we go through here, and we kind of do this stuff. Alright. Yeah, this was the medium, yeah. We didn't do this yet, so. Suicidal guy. Well, not suicidal. He actually wants to push you, right? He's trying to push me. But, you can make him kind of, like, fall, right? So, now, if we kind of, like, did this and we didn't react, right? He's gonna push you. It's kind of suicidal, isn't it? But anyways. Right, but that's how we want to do it, right? Okay, so let's think about that. There is this four-way right here. Let's get that. Get that other four-way. Right, so the idea is, if we don't get the four-way, we can't get through there. But this is good enough for... Yeah, let's keep on going. So this is kind of like a little Rube Goldberg kind of a thing. Right, so the idea here is that, you know, we can't get across, right? That it looks like an obvious path. Oh, maybe we can do it. Rah! I know the explosions go faster than I can run, so the idea is we can't get across. We gotta go up here, right? Okay. So now... I don't remember. I believe we just gotta wait for that guy to die. So this gate here is not gonna open until that guy kind of like lays a bomb and kind of explodes himself. So that's just the idea is we're doing like an event system. I don't know what kind of type of guy that was. I don't know if he was like a pre-programmed guy who kind of just kills themselves. So fan levels, I still can't complete this level. This is just insane. It's just only one fan level. But, so look, this is just ridiculous, but let's try to beat it. Okay, so, okay. Oop. Okay. So the next part is, wait for that. More stuff explodes. Okay, so it's this next part, which I haven't been able to really get to, is, we gotta, like, go down here and kind of, like, run for it. And then, once we're over here, it's up there in that corner, which is just really difficult. So I'll show you what I mean. Well, actually, hold on. What if you set these? Does that... Nope, that does not make anything easier on us. We should probably remove these hazards while we're here, right? Okay, so it's this thing right here. Like, first of all, if we don't get this completely right, we're gonna hit that skull. So this is like pixel perfect. I do not like this. So just... Ah! Okay, so we're up here, but the challenge is not done because these instant kills are gonna hit me right here on both sides. So I have to somehow get all the way down through... I can't go down into that pit. That's going to kill me as well. So I have to jump through here, and it's this part right here, where I have to go down and over. So I'm going to try down and over, and we're going to try to get through here. But I don't know, man. Okay, down, 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 down. Oh! Yeah, just right. So I'm not going to be able to beat this. I've tried too many times. We could try one more time, just for good measure. Oh yeah, one more time. There's my one more time. Yeah, screw this. Okay, I can't do this. Thank you for making an impossible level. Okay, Rush. Let's try this out. So Rush is kind of a pressure thing, time pressure. So right now, if I just sit, I should die, is the idea of Rush, I believe. So if I just sit, I'm dead. So we gotta keep moving. This is actually the secret way through. There's a little ghost that's kind of going through all that stuff. So this one is kind of a... Oh, there we go. I'm dead already. There goes that wall. So we have to not hit these fuses up here, right? If we hit these fuses, or if we hit the instant kill there, then we're dead. So where am I? How am I still alive? Is it Thursday? Yes, it is Thursday. So Sunday tasks are now Thursday tasks. So let's try this again. Oh, there I am, getting crushed again. Oh, I just hit that bomb. There's no way I'm getting out of here alive now. So we could try to jump in time, but just guess what? Now we're oh. Okay, let's keep on trying. Or not. You know, I was actually once very good at this, I swear. It's not like I programmed it or anything, right? But you know what I really want is... Oh, no. Is, right, like, even if you're over here, it's like, oh, you're down with the ship right now. Okay, so... Oh, right at the door. So this is... Okay, so those are instant kills. So if you touch them, you die. And I'm about to get crushed if I don't... Yeah, so what is that? I don't know what the time thing is. Yeah, if we get down here soon enough, then we can get here before these kind of like try to crush us, right? Ooh. Oh, and it even gets closed off. Wow, that's... Okay. So this is... Once again, if you stay in one place, you die. And, let's just hide up here. I don't know the... There's probably a less cheap way to beat this, right? So this is the... Or not. Let's try that again. It looks like we actually had something there. Because I think I did not originally design this level to be beat the way... Okay, you know what? Let's just beat it the cheap way. We're just gonna hide up here. And we're just gonna wait. There we go. Oh, not paying attention. Those are like sucker punch things, like you think you're through it, and then you hit those. There's also bottomless pits with the bottom. So let me demonstrate one of those. Hey, look, bottomless pit. We're stuck, we can't get out. Boom, right? Oh, crap. Okay, so, you gotta remember, don't hit the skulls. Okay, hold on. So let's say we're in here. Why not just die this way? Alright, so this is crushed to death. Let's try to actually beat it the way that I intended, which I think was like this. There we go. This one is kind of methodical. This is not... You have to move or you will die eventually, but it's more kind of methodical. I don't really like it. Nope, 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 nope. Damage, damage, taking damage, taking damage. I am down here and I am stuck. This is a death pit. Death pit, death pit. There's no way out. There's no way out. Okay, so... Okay. So let's demonstrate how to not do that. So let's reset that. Let's say we forgot to do that, right? So we're just over there. So let's say we wait right here. Now we're kind of stuck. Right? Comes at you, right? So if we're stuck over here, ooh, we can escape. Barely. Okay, so this is... Oh, we got a baddie coming for us. Okay. Okay, so they kind of chip away at stuff. Oh! That's not what I intended, but I guess we wanted more than one playthrough of the level anyways, so... Okay, this one is always kind of difficult. So we hit all these... Trouble. If we hit all the things on the left, that's trouble. If we hit everything on the right, we're kind of stuck in here. That's also trouble. So it's everything on the left except for the last one. Okay. And then that last thing, that last light fixture, we hit it with our head, and it kind of sucker punches us. Okay, so let's... Oof. That's a soft lock right there. I saw... Oh, I didn't soft lock it, but I saw a possible soft lock. Oh well. So that was Rush. Let's do normal. So this is Josh's levels. Hey there. So I see somebody stop by. So we're just... before Flash dies, we're kind of like going through... this old game to get some footage of it. So, here's the demo reels. If you want to take a look at... Oh, actually, I have to... Hold on. Actually, I'd have to... Hold on. Control F, JMIM demos. I'm searching for something. Here we go. There it is. And paste that into the chat. Okay, so anyways. Let's keep on doing this. So this guy died. Let's see what happened. What happened there? Oh, went there. Boom, right? Reset. He's over there. He's running towards the thing. Boom. So don't hit those things, right? We're saying skulls, dangerous, right? Over here, we're like, oh, we already know skulls are dangerous, but we're like really claustrophobic here. We gotta go one way or the other way. We'll go this way, right? Oh, hey, we can touch those things. Oh, wait, but we can't touch them for too long, right? So down here, we want to learn that this stuff kind of explodes, right? It leaves something behind. So let's reset that for a second and kind of see that. So if we go down here, and we see, like, over here, we can see this explode, right? We can also hit this with our head, right? Bam, bam, right? So we can kind of bust open these things with our head. Same thing with over here. We can kind of boom, 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 like that. Okay, I forgot what's a safe place to be, so I'm going to say right here. Okay, so that was a safe thing to do. Okay, so this level, it is designed to, like, make you accidentally hit that with your head. Also, you can chip these away, too. You can be like, bam, right? You can be like, bam, 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 right? So let's show that again one time. So, right, you can go boom, and then as you're going through here, the idea is that that spark is you're gonna hit the wall, and a spark's gonna come out. It's gonna hit those bombs. So ready? Spark. Right? Okay. Okay. Chain reactions, just wait. Okay, now we're through, okay. So this was more like a special effects kind of level where it's just like have fun and blow everything up. So you just want to touch one of those and hide over here. Ooh, God, I did not think I was going to get touched. Okay, we should have been more careful. So let's touch one of these. And just hide over here, I guess. Okay, so now that we're done hiding, and I think I just added this for fun, because it's like, woo, look at that, isn't that cool? Like, that, isn't that entertaining? I can just kind of spark this open. So anyways, this is kind of like really confusing, because you hit this, you're like, right? And then you can try to, like, hit it and run away. Oh, hey, I made it. Oh, but now I'm kind of stuck down. Ooh. Okay, so I know actually how to beat this level, because I've done it enough times. We want to hide up here. And we want to... Okay, there we go. Does that message activate? So there, that part falls down there. And then this we want to kind of, Right, that traps you in. Okay, so there we go. Let's, so let's say we hit this, and then we're like... Right, and then we're like, ooh, right? A little trap. I just want to demonstrate that. Oh, keep on. Okay, so let's hit this. Let's run for it. And let's actually get through here. So let's try to do both of them at the same time. Like, bam, bam. Right, let's not wait around. Let's get this done and over with. Okay, so here, right, we got more of these patterns where it's just wherever you've been before, you can't be again, right? Or for a limited period of time, right? Because there's no chain reactions, it's just, there, I got suckered. Oh, that little guy there, he, like, did me in. I didn't even see that, yeah. Like, I thought, oh, I've never been here before. It shouldn't explode. And then this guy right here, he just dives in there and just makes my day hard, you know? Okay, so over here, this is just a kind of like explode the light fixtures and make the things in there explode kind of a thing. Teaching you that the lights, the explosive sparks can kind of go through stuff is kind of what we're teaching here. And we want to hit that, boom, right? Open that up. So let's do that one more time because it's fun. And also because this may be the last recording of this game we take, so we might as well kind of like, yeah. Okay. So jump carefully, obviously. Oh, well, that's not very careful of me, was it? Carefully. 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 Okay, let's just wait. Less carefully, less carefully. And then this thing. So this thing, if we can get up here fast enough and get back, right, we don't have to wait, right? We don't have to wait, right? It's the safe option. Now, if we did this again and we're like, I've already risked all of this, like this is a big risk right here, and it took a long time to get through here, and I don't want to do that hard jumping again, then you could just take the easy route. The idea was to make this kind of time trial based. So if we, well, that was not right. Let's try that again. So let's say, you know, we've done all this hard jumping stuff, and we don't want to risk it again. We even carefully went down here. And it's a time trial, so somebody else would beat us, because they'd go, you know, up here and hit this. But we're going to wait. We're going to just wait at the door, and we're just going to wait for it. You know, we're just going to wait right here. So, right, this is just to teach you that it's pixel perfect. So because these bombs are only like one way in each direction, I'm safe as long as I'm on this platform, right? So we can kind of do this, and we're safe. And that's a little thing to teach us, so when we're over here, we hit this, we're dead, right? But if we hit this, well, we don't explode at all, right? Because it's a different material type. So the option is to be right here, right? And now we're safe. Now this is annoying because we chip off parts of the platform as we go. And I'm being stupid. Not paying attention. Come on, let's get this done and over with. Let's, okay, so. Let's try to do this faster. Not fast enough. Okay. Okay, so. Oh. Not perfect enough. Okay, so. Okay. Okay, so let's do this. Boom, 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 and then get up, get up, get up, get up, get up. Okay, cool. And then to the exit. I don't know what just happened, but he definitely killed me. Okay, so this thing, we got these switches, and if you kill this guy, this opens, right? If you kill this guy, right, we're not going to fight him at PAX, we're just going to keep going. We're going to send him to his death. So we could probably get him over here if we wanted to. Or we could do that. So he's getting crushed, right? So we wait for him to get crushed and then we can get through. Okay. Okay, so this... Woo! I got lucky there. I'm not usually that... Oh. Okay, so now, this part. Let's be careful. Actually, let's do this. Nope. Oh. So I was trying to be like, instead of like dealing with it, I'm like, you know, let's try to kind of cheat here and kind of, yeah, there we go. Okay. So this is annoying. I'm not really a fan of this level. It is actually kind of fun because it's like we got all these locks that we've created. And I gotta, like, unlock these things. We need some animation for the flame thing, but, oh, well, whatever. So we have this stuff. Let's kind of hit this. Hit this. And I'm not gonna play this one again. I hate this level. So, let's just keep going. Run, I guess. Yeah? Yeah, run. Run would be a good idea. Right? And then... in the floor. Let's not hit that floor. Let's go up. So go up and around. We traverse the same path, but now it hits that instant kill, hits that switch, and doors open. Where am I? I don't even know where I am here. Let's just hide over here and hope that everything is okay. There we go. That was good enough for me. Okay, so I see. So this, actually, does this let you kind of... I don't know if that was the case. Might have been. try a different route through here. Let's try up and over, because it's harder to go up than it is to go under. And let's just roll back around here for a second, because we forgot this switch. There we go. Exit. So this was kind of cool, right? So the idea is like, this is really slow to get through here. And if we hit this thing here, right? The idea was that, you know, we might not be able to get through in time, right? And we get smashed, right? And so we want to make sure that it's easier to run through. So we hit this first, right? And then it's like, oh, that's nice. Now we can run through here, right? And then, right, obviously that's going to kill you. And so the proper solution. So we hit this. And then we hit this. And then this bridge falls, so we have to start kind of making it over. So, let's actually beat this. This is not a hard level. I just want to demonstrate kind of the mechanics that are going into this. So, we explode this. And then we can kind of explode this. We can run to the edge. We can go, woo! Okay, so this is actually hard. It's one of those more annoying levels that I don't like. Okay. Let's play it safe. So you can play this kind of safe, or you can play it kind of dangerous. Let's play it a little bit dangerous. Excellent. Oh, I got suckered. Like, that's not quite fair. That the game that's my fault that I programmed the game controls like that. Like, that should just let me run over that gap, but it's not as consistent as it should be, and so I don't know how to. So now it's like, oh, I did all that good stuff, and now I'm just kind of dying all over the place. It's like perfect run, and now I'm just like, ugh. Okay, come on. Come on. Okay, come on. Through here, through here, through here. And then let's kind of... Let's not wait around here. Let's just get this done with. Okay. Okay, awesome, awesome. Okay, yeah. Okay. Oh, okay. I was like, wait, I thought I did this. Okay, cool. Okay, so this thing, I don't even know how I'm supposed... I thought I was supposed to, like, go like this. Oh, yeah, like this. And then like that. Oh, there we go. I spent a lot of time trying to beat that a few days ago, and I couldn't... Oh, yeah, that might be a problem, isn't it? Break these with your head. Okay. I don't know why I did that. There we go. And then destroying bridge thing. And there's a lot of different, like, design patterns in how you can, like, put together this level, put together levels. And so I kind of want to document this. So here we are, here we're at the exit. Now, let's try that again and say we did not push any of the buttons. And we're just like, don't push those buttons, right? Let's just kind of get down here like this, right? So we're going to get down here. And we're just kind of stuck there. Now, I think we could soft lock this. So I think that if you did something like... Yeah, we're soft locked here, I think. Or do we have to, like, go back? Oh, nice. Okay. So there's a way not to get soft locked, but it is a little bit convoluted, but we have a measure to prevent that from happening. Okay, cool. That was not good. Okay, so we gotta remember light fixtures. Light fixtures emit sparks. Sparks will kind of like... There we go. We don't even have to jump. We just kind of had to use our momentum there. Let's go through here. There we go. Elevator of death. Oh no, not right. I tried, but I did not jump at the right time. Bam! Oh, you get suckered in the middle, too. Okay, so I gotta jump kind of lightly. No? Come on, I know there's an answer here. The answer is cheat. Oh, or that. Okay, how about we try... Yeah. Oh, God. Ha! Yeah, there we go. Okay. So let's say you didn't do this right. So, actually, this is a soft lock. Oh, no, we can get through here like that. So let's say we didn't do that right. And let's say we didn't press all the buttons. So let's say we kind of went through here, and we forgot that last button because we were, like, panicking, right? We're panicking, and we don't get one of these buttons. Let's see what happens. Or let's just keep on dying from explosions here. Okay, well, let's do this. We can do this. We're good enough. Or that's an interesting option. Okay, cool. So we skip that button because we're like, screw that. And then we're like, uh-oh, right? So you have to hit all the buttons or else you get locked in there and the explosions from behind just take you out. So we gotta hit that button right there, and then we can kind of keep on going. And now this kind of goes through, right? Okay, so this is, an interesting puzzle. So let's actually die for a second. So you're right here and you're like, how am I gonna make it through here? So, oh, there's a bomb right there, how do I escape, right? Or, oh god, there's bombs, what do I do, right? So you're over here and you're like panicking, oh no, how do I get through here, right? So the solution doesn't look very obvious, right? It looks like, you know, but remember, there's a delay on these bombs, right? There's a delay on the proximity vines, so you gotta tap it like that, then kind of run away a little bit. So we gotta tap, and then go over here, tap, right? And you only need to do it like for one, so you can actually kind of... Right, so you gotta be kind of methodical. And now you notice these kind of purple tiles, they are indestructible. So even though these four-way bombs here can go a very far distance, I'm shielded by this dragonite tile, or whatever you want to call it. I think we're calling it dragonite or something. So once again, like if we... Oh god, I went way too far. Okay. So yeah, we're shielded, and then we can kind of go through here. And I don't know. I thought that would be the correct way. Okay, there we go. Oh, sucker punched. Okay, let's hit this thing here. And then I think this actually might lock me in. No? It's not one of those lock you in levels, but it is definitely one of these, like, very kind of, like, crazy, like, stuff all over the place kind of levels. So let's hit this thing. And now, I think we're good. I think that was it. Oh, that's locked, so we gotta go down here. And, oh god, I didn't mean to... Okay, 1, 2, 3. Almost. Okay, so there's a timing thing going on here, right? Where we gotta, like... We gotta hit... We gotta hit the... Okay, so... The stakes are kind of high, but what we could do to, Well, first we gotta hit that. So we're going to hit that 4-way down there. We're going to try to wait for the proper delay, and then we have to just jump at the right time. It's just it's a synchronization kind of thing here. So we're going to hit... Actually, no, hold on. There we go. It wasn't that hard. Okay, so this is one of those same puzzles again where we have to hit this, go over here, hide over here. And this level just was very convoluted in the way it needs to be beat. Right here, that's going to kill me if I go down there, right? And so it's not that way, and I don't actually remember how this is supposed to be beat. All I remember is that the answer was less obvious than I remember. Like, you think there's the obvious path, but it's like this other indirect path. So we kind of have to keep our eyes out for... like, right down here looks like a good path, but then if we go down into here, we're dead. And if this blows up, we can kind of go down into here, but then we're dead over here. Or actually, no, we can go down here, wait for an appropriate amount of time, hit these, make them explode, jump at the right time, and then we can get through down to here. But even if we... Oh, this is vertical, right? Yeah, this is vertical. So we could do that. We could try that. So let's try that. So... Okay, so... Let's hide over here for our lives. So explosions, chain reaction. So we need some kind of surgical precision here. So, surgical precision... Oh, I see. I see what it's going to do. It's going to kind of really kind of make it hard on us. Oh, so you have a little exit, so that's nice. Can we get more exits? So we're going to hit that. If we hit this and hit this, they're going to go right away. We're going to hit this later. So we got to hit this, we got to wait, then go over one. And if we do not do that correctly, we're going to die. So... Wait. Go over. Jump. Nice. Ooh, oh, a sucker punched. So, the thing is, that's why I don't like these designs, because that went in a different direction than I thought it was going to go in that bomb. I thought it was a vertical explosion, but the bombs should actually clearly designate which direction they explode in, because... then I wouldn't have made that mistake. And I get that, oh yeah, I should just be familiar, but we want to be able to process this kind of at a more instinctual level than that. So let's, is there any advantage to opening that up? So this vertical thing kind of explodes, hits that. Does that give us any advantage? I don't think it does. I don't think any of this is necessary. I think it's like a long con, Josh's long con to screw me over and kill me is what I think that is. So let's not do that. Let's go over here and try this out. Without trying to... I'm just scared I'm going to hit that instant kill thing. Okay, so let's hit this. And... more surgical precision here. Okay, that's good. Oh, I see. If we want to get to here, we got to go down there, don't we? There's no option. There's no other option. We got to actually do that. So, let's do this. Ah! Okay, so this is obviously going to be a pain. Let's try to do this for completeness. Okay, so we know we actually have to do this. It's not just a long con. And this part is actually, I think, harder than... Let's just hide over here. This part, I think, is harder than the part over here. So let's just do this first. Okay, so we know we have to go down here. And we have to wait. We gotta wait a little bit and hit the one to the right. Wait. Go to the right. Jump. Okay, there we go. So this thing right here is the trick. We hit it, it's horizontal, right? The flashes kind of tell us that. Okay. Now we can go back over here and continue demolishing the rest of the level, right? Okay, cool. So, let's go down here. Very carefully, run away. Wait for things to explode, and I think now we have a path, hopefully. Yeah, we have a path. Screw those other things. We're done here. Okay, so. What do we got here? We gotta wait a little bit. We got these delay things. Cool. Can we just go through here? We don't even have to go down there. Ooh, oh god, oh god, oh god, oh, okay, come on, come on. Oh, no! Okay, so I think we can do that. It's just that... We just gotta wait, be patient. Oh, okay, well, I swear this is doable, so we're gonna keep on trying. So we gotta wait. There we go. Then I can... Oh, what the... Okay. It's that pixel level of precision here. Okay, hide. I'm scared. Okay, hit this. Okay, so now we can run through here. And I don't know, just keep on going and try not to die. So this is right here. This goes around. Cool. I think we're good. I think we're done here. Oh, okay, so that's kind of annoying. Let's try the other path, since we already know how that's gonna go. Keep on getting sucker punched here. Or, I don't know, sucker bombed? I don't know what you want to call it, but over here, let's... Slopes, man. Oh, well, now we're down here. I guess we're doing it this way. Okay, so... Go down here. Go down here, run for a little bit. See him coming towards you, jump over him. Oh, ooh, ooh, oh! Oh. It's hard to tell the difference between the lit up ones and the not lit up ones I'm seeing in the design. I think that was a bad idea. So, yeah, art matters. The style of the... Okay. Oh, ooh, ooh. So how is... Oh, I see. It's not going to let us off that easy. We got to go over here. And hit that. Okay, cool. Exit. Oh, one of these things. One of these pixel perfect jumpy deals, huh? Okay, so woo! And this is a timer thing? Doesn't look like it. Nope, just a fancy explosion thingy. Ooh, but this now... Okay. This is a pixel perfect-y jumpy deal. That makes me want to be like Josh. Okay, let's just... there we go. Nice. Gets worse. The last level on this is just like this intense... Ooh, it started to lag on me. I might need to reset this game. Oh boy, yeah, it's starting to lag. I probably have some type of memory leak I don't know about in the game, and... we could try this way. Why not this way? This way is impossible, maybe? Okay, so you know what? I hate that way. I'm gonna go with this way. Okay, so let's try to get through here alive. Let's just run. Let's just run through here like that. Yeah. How about that? How about not that? Oh god. Okay, so cool. Ooh. Don't jump too high, you hit the ceiling, you make it explode, and oh wait, we gotta run. Because once we, the explosions there will seal off the, it kind of soft locks you, which I'm not really a fan of, but it's kind of cool idea, right, that you gotta get through here quickly enough, or the gates kind of close on you, and you are doomed. So we're going to try to make this through here. So once we hit that, we set a timer, right? There's a chain reaction timer. And I believe, I don't know if hitting, well, actually, if we hit those bombs, it kills us. So I don't know why I'm kind of like, oh, I believe if we hit them, they kill us. So we got to get through here in time. So just kind of, ooh, explosions. Okay, we're through there. Okay, oh, sucker punch. Okay, so come on, keep on going, keep on going. Okay, so this is annoying me. But I really want to get through all of the levels of this entire release, just so that we have something later for, to show kind of off if we ever... Ooh, that was close, that was close. Oh, no. Okay, so see what I mean about sealing you off? Where if you're not like completely accurate about this and do it kind of completely quickly, then you're dead. You're dead because it seals you off, right? Like right here, bam. Whoop. Oh god, jeez, that was lucky. Okay, so over here, let's try to get through here. So when an explosion hits one of these things, if they not when it hits it, but if a flame piston loses its foundation that it's glued onto, it will disappear. And that's just to avoid people from doing things that I didn't like, I guess, in the game design. Or, I don't know, I created death traps, and people would subvert the death traps by clinging to the piston. So I kind of prevented that by making sure the pistons kind of disappear if they lose their foundation. So this is not... Let's hit this. Let's do that again. Okay, there we go. Much safer, right? So you can approach it from a safe play. You can play it safe or you can play it dangerous. Let's see if we can just run. Yeah, there we go. That one instant kill just kind of there to... This, I believe, needs things pressed in a certain order. Like, if we just paint... If we just press everything in the wrong order, I don't think we can beat this. So I believe we saw that sometimes pressing things in certain orders kind of destroys some of the pistons, and then we can't cause the chain reactions we need to cause, and then we just gotta commit suicide. Okay, so over here, I think we gotta touch the one on the very top, right? We made it so that made it difficult. So if we touch the one on the very top, we just want to make sure that we don't destroy any pistons, and I think that's all we had to do, right? So if we hit this, there we go. So those two work. So we don't have to hit all the buttons, but we had to, ooh, okay, here we go. Okay, come on, we can do this, we can do this, we can do this, we can do this. Instant kills. Okay, oh yeah, there we go. First time. Okay, so this... Josh made this. I didn't beat this the last time, I don't think, or I was very annoyed, I'll tell you that. But we're gonna try to, like, smoothly navigate this free fall here. And... almost. Almost. We're just hitting that last one. That just getting killed on that last one. There we go. Okay, so this thing, I don't know, man. Let's just go down here, hope we don't die. And we kind of did it, but oh, look at this. We're stuck at the gate. We didn't press that other button. Oh no, and now we're dead. So let's try that again. Okay, wait for... So that's interestingly timed, right? It's like timed to be like, okay, alright, that's kind of cool, alright. And then... Okay, and then, are we at the last one that's... No, we're not at that last one, but we gotta kind of... So this is Harder than I thought. Harder than I remember. It's those... Okay, so here's what we're gonna do. We're gonna cheat. We can cheat this. We don't gotta wait for this. Let's just kind of jump around. Woo! Okay, not quite. Not quite. I think we could kind of pull that off if we kind of... If we... Yeah, I think it's... If we could pull it off if we kind of... Ha! There we go. Yeah, I'm not gonna do that. There we go. Nice. Okay, so what are we doing here? Interesting, interesting, interesting. I guess I'll just wait. Oh, no, because now we're kind of... Alright, so we actually have to beat that. We have to kind of... We gotta hit this, and we gotta... Oh, no, this is horrible. Why? Okay, so we're gonna try. And, oh god, where do I hide? Where do I hide? Where do I hide? It looks like I want to hide over here? 1-2, that's a 1-2 punch that's gonna kill me. Over here, this would be safe right here, even though there's blood all over it. This would actually be safe right here, it looks like. So I think we've got to hide right here for a little bit, and we gotta wait. So we gotta run for our life, but then we gotta wait at the right point. So we're gonna wait right here. Or not. Or not. That's still... Okay, so that's not quite right. It might just be a well-timed jump. No, because we have to hit these vertical bombs. If we hit these vertical bombs, we can get them to go bam down here and hide right here. So we gotta go like... We just gotta nick it. Okay, so let's try that. So we're gonna nick that. Oh yeah, like that's gonna work. I mean, no, I think it's gonna work. It's just that this is designed to be infuriatingly difficult. So we're just gonna. Yeah, I don't know how we're gonna do that. Ooh. Oh, so close. So I gotta, like, go hit this and then run around over here and hide. But very carefully. Okay. Ah. Okay. So it's like I overcorrect, or I'm like, I hit that thing, and I'm so careful about not... by doing that precise thing, and then we kind of have to, like... We have to be, like, quick and precise, and then we gotta, like, slow down. Yeah, I don't like this level. I think it's too hard. Too hard, too hard. Hate it. 0 out of 10 stars. Okay, so anyways... Okay, come on, come on. Okay, this is just infuriating. Let's see, is there another way to do this? No, that looks like the only way. I mean, there's those things there. There's the only thing we can touch. It's the only thing we could possibly interact with. There's nothing else to interact with here. Oh, come on! So it's like, the thing is that we kind of nick the spot, the other one, a little bit. And then it, well, it doesn't matter, because the vertical hits the four-way, and then it hits the other verticals. And then we have to run all the way over here. We gotta be pixel perfect about... There's we gotta be pixel perfect right over here. That is kind of lame. Okay, so let's just... Okay, so, here. We gotta go down here. We gotta go over. See, like, fuck this. Okay, so... Let's just keep trying. Okay, so... Okay, so we go down here, and then we gotta run far enough, and so I can't just tap, 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 right? Because by the time I do, like, little taps to get over where I need to be, already too much time has passed, and I'm already dead. So it's like we gotta, like, pixel perfect kind of run over there, right? And I keep on stopping early. In order to get through here without dying, we have to actually kind of hit this and run. There you go, like that. Okay, finally. Okay, we're out of here. Screw that level. I hate that. That level sucked. I hate it. Okay, but anyways, let's keep on going. So this is a timer kind of thing where we got to get through here before these gates kind of close on us. And I don't know if I'm going to make it. Oh, just close enough. Let's try not to get the skulls to kill us. So this I don't like. I can tell this is one of those kind of like pixel perfect-y jumpy thingies. And I'm kind of sick of them. And I know the next thing after this, like the last level, is just like ridiculous. So it's like... I guess we should wait for everything to explode just because, you know, reward ourselves. This thing is like an elevator of death. And I think the one place we want to save ourselves is like right up here. Where if we hide right up here, we might actually not even have to do anything. I don't know how this was designed, but it might be safe, like... Okay, so we're not quite safe right there. So it looks like it moves a little bit right before... There we go. Oh no, does it seal off the door? Come on. Okay, no it doesn't. Okay. This thing, though... So I kind of like... this here, because once you get through here, we just gotta go bloop, bloop, and I think this is actually going to be easier, but I don't know. Oh, so close. So we got the bottom one, so I mean, it's not... Nice. Okay, so this I did not complete last time I played this. I absolutely know it because it's like... Because look at this. Do you see how ridiculous this is? Boom! So close. Well, not really, because we still gotta... We still gotta... I mean, I'm doing better than last time, that's for sure. And now I'm just, like, sucking. I got lucky, and I'm regressing to the mean. That is what's happening here. So... So, it's also a thing where keyboard pressure matters, right? And if you don't apply the right keyboard pressure, you get your ass handed to you. So, I mean... Come on, I was just coasting there. I was like, I'm good. I'm good. I can relax. And then I'm like, oh wait, not down there. Right, because we have this right here. You dodge this, you're like, ooh, I'm fine, and then bam, right there. Just... Okay, I'm getting sick of this. So I have never beat this level. I just can't do this, man. Yeah, I can't beat this. I say that, but then I keep on going. Okay, screw that. Next level. I think this might actually be the last level. We might not actually be able to do N for next. Oh, there's a next level. So, you know what? I hate these instant kills. Like, no, they're not bad. It's just when they're bad when they're used for, in terms of the design, I think it's bad when the instant kills are kind of used for this pixel perfect navigation here. I find that absolutely infuriating. It's just like, it's right, like that's, screw that. Okay, so I think, let's see what else we got. I don't even know how this is supposed to work. I guess we're just supposed to run and wait, maybe? Because I see those horizontals look like they're about to sucker punch you. Like when you go through here, like they're gonna get you. Oh, nice. Okay. And then, that's kind of fun. Like, I do like this. This is kind of fun, where it's not too crazy. Oh, I see. If we do an arcing jump. If we do an arcing jump through here, we're dead because we waste time. And so we actually have to go straight. Oh, I see. Oh, this is called You Win. This is the last level. Nice. You win, but then it also kills you. So you would think that this would be kind of a fun kind of a level. Let's just... But yet, here we are dying. How did I do it the first time? I don't know. So we gotta make sure not to get killed by the skulls right down there. Okay, don't get hit by the skulls. Kind of arc through there, and then run for your fuck. Whoa, wow, that's kind of intense. That's kind of fun. Oh, that's not fun. So this looks, I like this design here, right? It's not too difficult, right? You got the instant kills all over, but they're not kind of used in a pixel perfect kind of precision way. I mean, I guess that jump right there is kind of difficult, but by now, you should probably have played the game enough to where you can manage that kind of jump. And then this guy, he's a punk, and we gotta get, oh, we got two little punks. Oh man, he is... There we go. Oh, so you had to get rid of both of them. I wonder what happened if they both died at the same time. That might actually not work out for you, would it? So this guy... what's the point of this? Why do we care? Why do we care about this? Well, let's just... Well, he's dead now. An orb will unlock it. Oh, so you need at least one... Okay, cool. So that was normal. What about intro? Intro was the thing we already played, right? I think? Unless there's a different intro level set. Yeah, so this is already the same intro level set. Okay, so we have intro, and then we have HCAPC. What's this all about? Is this like different, are these different things where they have two separate levels? Yeah, this is up, so... Okay, so let's do all of the normal doors, and then later we'll do... Oh, nice little thing here. Okay. And then I'll just wait here. But if I wait here, I am in trouble, aren't I? Oh, that was cheap. I did it. It was kind of a cheap shot, but I did... Oh, hold on. Ooh. Okay, so let's just do the easy side. So we want to just do the normal doors right now. So let's just do the normal door. Let's not forget about that hard door. So the idea for this, I believe, is there's 3 parallel level sets. And at any time, you can go back to the hard level sets if you can get to the hard door, right? So you can have, like, any path through the game you want. There's just, like more than one exit I thought would make the game kind of interesting, to where if you couldn't figure out one way, you would have another option to get out, right? So that's the hard door. We don't want to take the hard door. We want to take the easy door. Okay. And this is... Oh, we don't have to do this. This is like the hard door right here, right? This is the hard door. we want to just go through here, right? And take the, not the easy door, but the medium door. I don't know why I'm doing this. I think I'm ending up at the... Oh, I see. You get demoted, right? So if you can't at least get to here, you get demoted. I see. Okay, fine. I think we could just run... No, we can't just run through here. We gotta... Ooh, that's kind of scary. Oh, that's kind of scary. Oh my god. Okay. Okay. Anyways. Did we press the button we need to press yet? Or no, we did not. So we gotta kind of go down here. Press some stuff. Wait over here in fear. Okay, now we can get to that lever. And now the door is kind of open for us, right? And, ooh, this is kind of scary. Okay, so we gotta hit this, and I guess we gotta kind of go over here like that, and, oh, we did not wait. If we were patient, we would have been okay, so let's just try to... Nice. Okay. So then down here... Okay, we did not... We gotta be more patient here. Okay. That opens that. We go down here, we can hit this thing. We can go over here, we can go down here. And this thing. We want to hit the lever, and I think we just want to hide over here, don't we? Until that thing goes down here, and then chain reactions. Okay, nope. I just thought it might, but... Okay. And let's just kind of hide over here. Oh, I see. The little path to the hard door goes away. Interesting, okay. I don't know what I'm doing. I'm just kind of running through here. I see all these instant kills, and I'm like, this is not cool. So yeah, once again, I don't like levels like this, where it's like instant kills all over the place, pixel-perfect jumps, and if you don't pixel-perfect jump, then you're dead, right? I don't really like that. Oh, this looks kind of fun and interesting. Let's just kind of, I don't... Oh, it's not the right way. And, it's gonna... I'm gonna hide over here. Oh, no, I can't hide over here. Oh god, it's a little bit... Okay, wait. Okay, well, we're fine. Not fine there. We gotta jump over that. And, okay, I see there's a path down there, but we gotta get all the way over here, and then we can kind of just hide. Let's hide. Oh. So, we gotta hide to the left, hide to the right, hide to the left, so... Okay, so now... Does it block or exit? Is it an exit blocker? Okay, no, we got a little entryway here. Okay, cool. And I don't think we gotta spend these right, don't we? Yep, we didn't do that right. So we gotta open up one box at a time and just finish off one of these guys, one at a time. Oh. And then finish off... Actually, no, can't we break the lights? Oh, no, the lights are not over the, There we go. So what's this guy do? Oh, we gotta run... Oh, he's just a little suicidal guy. He'll just do his thing. There we go. Okay, this thing is horizontal, vertical? I don't know. Well, we found out. Horizontal. Jump! Oh, sucker punched. Okay, so if we get the vertical, though, can we just survive? Oh, there we go. And this guy, he must lay bombs, right? Or not? Like, how... Ooh, he's gonna put me into the geometry. So he doesn't lay bombs? Then how do I get through this? This doesn't make any... Oh, there... Ooh, okay, so he does. I'm just gonna wait up here. Okay, so they do lay bombs. This guy, though, he's just a pushy guy. Okay. Okay, interesting. Just gotta make the right choices here. I'm gonna try to make some choices and hide is what I'm gonna try to do. Can we just... Let's try to hit... Ooh, no, okay. Can we do that quickly enough? No, it's pretty fast. Ooh, did it. Did it. Okay, so then we could probably hit this thing down here, right? I don't know if I'm doing this the way it's designed to be. Ooh, designed to be, but, you know. Everything here is going to destroy me, isn't it? So I guess this is my only option here. And then now... I'm still in some serious trouble, aren't I? Yeah, I'm just gonna plunge to my death unless that... Like, there's nothing there that's gonna open up that door. Was there... Oh, well, this... Okay, so I would say that there's, you know, something here about the order. So, this was an instant kill trap, so I'm gonna guess that, you know, we weren't ever supposed to touch that. I'm guessing. And this looks kind of hard to grab onto, so we're gonna hit that thing. And I bet... No, let's not do that. So those vertical bombs are gonna come down on me. Oh, but I have a little hidey hole over there. Let's go to the hidey hole. Hidey hole. Nice. And... Okay. Alright. We're still not out of here, though. Okay, okay. Oop. Let's hide up here for a second. That'll work. That'll work. That'd be enough. Okay, let's go down. Cool. This thing, I've never seen this before, I don't think, or it's been such a long time. Oh, I see. Little chain reaction, that guy opens up a little box, he goes in there, he hits those things. And I was just trying to see what kind of chain reactions I could make happen using the AI, because I thought it was kind of interesting. It looks like this is just a, ooh, if we're not careful, he will actually kill me. So let's jump up here now. Okay, so now that, ooh, big kill switch, oh god, okay, we can probably hide here, we'll probably be fine. Okay, and then we're soft locked? Yeah? I don't know why I designed levels that would soft lock you like that. Like, why would I do that? But I did, so let's reset. So we know there's this long kind of like drawn out, like these guys activate things that blow up stuff, and I don't think both of them are supposed to be alive right now, that one of them just got kind of lucky. So we're going to hide up here now, because we know that we get soft locked if we're down there. We're just going to wait for the little guy to kind of do his jumpy business and kind of, come on, you can do it. Okay, so now we'll just kind of go over here to the exit. I'm at the mercy of something here. Oh, that guy. Okay, so this guy's probably a pushy guy. We'll throw him in there. And then pixel perfect jumps. And oh, wrong way, wrong way. I saw it was the wrong way, but by then it was too late. So wait for him to hit those mines. And we have to... So really I need to make it so in the game design where if the floor blows out on you, it shouldn't kind of destroy you like that. Oh, so that's why he has a little ladder, right? Because if you bring him down here, we want him to be able to come back up at us, right? Yeah, that's why there's a ladder for him. Okay. Okay, so this thing, it's a 1-by-1 explosion, so if we kind of go up here and hide, we'll be fine. Oh, okay. We didn't even have to worry about that. We can kind of just go. Okay, and we're good. And we're trying the normal difficulty right now. So if we... Oh god, he can blow stuff up. And that's what he's gonna do. You're number one, boss. That's weird. So it brought me back to... Oh, no, I see, okay. Path of least resistance is the easy door, right? So it's like, if you want to go to the non-easy door, you have to work for it. That's what's going on here. Okay, that's fine. Ooh, okay, so there's the medium door. We want to go to the medium difficulty door. And it looks like it's going to make it actually... come on. There we go. Come on. Yeah. Okay, so let's try the easy stuff. So we tried the mediums. So let's try the easies, right? So anytime we find a down, anytime we find a door that's for down, we're gonna go down. And so it looks like right away we don't have. I don't know if we have to pick the easy levels right away. So let's exit for a second. No, I don't think we can. We gotta pick the levels right at the beginning. So that's not how that works. So let's hide over here. And then we just want to time this to jump at the right time, right? I don't know if that's the way we're supposed to beat it, but that's the way I've been doing it. So that's still a hard door. So let's just keep on going until we find the easy door. Is there... Nope, still not an easy door, so let's keep on going. Easy door, there you are. Easy door. Let's go to that easy door. See what our easy levels look like. So I'm expecting things to just be juvenilely simple here. It's kind of fun, because it just kind of shows you, hey, look, I can break things with my head, right? Oh. Okay. I don't know if this is easy. Well, the puzzle difficulty is definitely easy, that's for sure, but it's like the... What? There's no way to beat that. Oh, wait. Oh, yes, I see. Okay. Alright, the whole level is kind of teaching you, hey, break some stuff. And then you're like, there's no way past that. There it is. There we go. That was kind of, that was kind of cool. I like that. Because you were, like, tasked with something where you're like, that's impossible, and you're like, wait, what have I been doing this whole level? I've been breaking the stuff with my head. Maybe there's, like, a reason behind that. So, it looks like we can hide by this switch, so let's kind of, like, hide out here. And then let's ask ourselves, why is this an easy level set? Because this looks infuriatingly difficult. Like, who said this was easy? Like, look at this. Look at this. This is ridiculous. Right, if we accidentally hit those light switches, we're goners, right? Right, like, right there, like that. Well, how is this an easy level? Maybe that wasn't the intention of the design? Maybe... Great, and we even have to jump on these with, like, an interval, right? To, like, we have to, like, cook the grenades, right? We're grenade cooking. Okay, so... What if we do this? Wait. And now... Oh, no, that doesn't work either. I mean, it kind of works a little bit better, because now we can kind of just do this. It's more jumps, but, this is even more tedious, though. Okay, so this last one, and then we're done here, right? Okay. Oh, and now we gotta hit the... God, we gotta jump all the way back? Ah, so... Okay, so that's not a fun level design. It's like, it's fun if you like, very difficult stuff that's just, like, annoyingly difficult. Yeah, this is fun, but for me it's like... Right, the pressure's on, right? Because it's like, you already did all that work, and now you have to, like, jump all the way back. No, I hate that. So there's certain styles of levels I like, and that's not one of them. Now, when you're doing the game design, you can, like, create level sets for different styles of play, and that's fine. It's like a dig dug kind of thing here, like boom, 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 boom. Kind of fun. But what are we actually doing here? We're just trying to get to that door. There we go. Okay. So this is what I'm talking about, like destroying sections of the level and being able to like navigate through them. In fact, this is a great example. I'll probably want to take like a screenshot of this eventually, or like a little animated GIF, because this is really good right here. And after this, we just gotta do the hard ones, and we'll have played every single level in here. We haven't, well, we will have not 100%ed it. We didn't beat all the levels, because we were like, screw this on some of them. But we did a pretty good... We did pretty good, though. So, oh, is this we gotta do, like, one at a time? And if we do this, we can hit that. Oh, I see. Nice. And this is just a very careful staircase. Oh, I see what they did there. I don't know who did this one. Was this me? Was this Josh? Who made this? I don't know, but I'm angry at them, whoever they are. So I think this is misdirection. I think it's... You want to try to go up here, but you can't jump that high. Look at me, I can't jump that high. What am I doing? Even if I go straight vertical, I can't. So what makes me think I can do it at a diagonal, right? So this is right, this is a misdirection, purposely. Oh, hey there. So I see somebody else is in here. I'm just going over the old game that I want to make a new engine for, like a non-pixel-based engine for, because Flash is going to be discontinued with Chrome right on New Year's, so I'm just trying to go through here and play all the levels. So I'm on, like, the last set of levels, and just trying to 100% it so that I have some good video footage of this stuff, because it's going to be a pain to... Oh, there we go, now we got a little staircase. It's going to be a pain to try to play this stuff after 2020. I mean, we can find SWF players, and I think Newgrounds has a Newgrounds player and whatnot, but it's just going to be a lot harder. So we're just going to play through all the levels, and we're through most of the levels already, but there's still a bit more. The basic idea of how this works is it's like Bomberman, except the bombs are proximity mines. You can actually touch them, but then you set a timer, so they're like kind of grenades. So, for example, with this bomb, I can touch it, or, well, not if I... Okay, so this is an instant kill. That's an instant kill bomb. So you touch it, you die, because it has a little skull. But the other ones you can touch, right? So over here, like these bombs over to my left, I'm going to touch them, and they set a fuse, and there's a timer delay, right? And then unlike Bomberman, when they go off, there's a little delay, right? So you can cause these chain reactions that you can see. In Bomberman, all of the bombs that are connected will just go off all at once, and you won't be able to make these timed Rube Goldberg kind of chain reactions, right? So, certain materials have different properties with respects to how they react with Alice and how they react to bombs. So, dirt is very soft material, and Alice can kind of just hit it with her head and break it open. And when she breaks things open, she leaves sparks behind. And if a spark hits a bomb, that bomb immediately detonates. So you saw me kind of earlier try to demonstrate that this bomb could be touched and then it immediately killed me. What happened is I jumped up and I sparked the ceiling, and that ceiling spark detonated the bomb. So I want to approach it from going up, hit this here like that, wait for it to go off, and then kind of go back here and approach this by not hitting the ceiling above the bomb, because if these sparks hit the bombs immediately ignite. So we're gonna have to just surgical precision here, kind of like be very careful, kind of hit one of these bombs one at a time, and just wait. Okay, so we got one more. Oh, so I did all the programming for this. I did the lighting engine, the AI, the actual controls for the player, the level editor. I did... What the heck? How is that fair? Like, what is this? This does not look finished. There's no way this could be finished. There's no way you could beat this. Oh yeah, there's not even an exit door on this. Look at this. There's not even an exit door. So, the game was kind of unfinished, right? Because it was done in Flash. And so, like, all this kind of crazy stuff. Like, let's take a look at the intro here, the intro levels here. Hello? So the intro levels kind of have kind of a demonstration of the basics. So, right, you have materials that can fall, and they shatter light fixtures. So a light fixture, if it hits a moving object like this, there's a delay before it shatters the light fixture. When this moving object hits these bombs, it immediately explodes, because it's like a big piece of falling debris, right? So if falling debris hits a bomb immediately explodes. So you got to think of these bombs as kind of like proximity timer grenades, and but if you hit a grenade with a hammer or something, right, it's going to immediately explode. Also, these pistons up here will emit a spark that detonates the bomb. So like this, like that, right? Okay. So the lighting engine, if we break all of the lights in the game, it goes into kind of like this dark mode. So if I hit these switches here, these switches emit sparks, and the sparks are going to hit each one of these lights. So if we can hit all of the switches straight down the middle, everything's going to go dark. So I'm going to show you what that's all about. Hit this. Nope, that wasn't quite right. Reset. Nope, not quite right. Bam! Everything dark, right? So, what else? So this right here, you hit this, chain reaction explodes that, right? So, different materials have different properties. So, when you, this vent material is indestructible, but it allows the flames through. So the flames from the bombs can get through this vent material and hit these light fixtures and open up this barricade right here, right? So we hit this, and then we can get through. Okay, so now let's exit this. We were on the last level set here, HCABC. I actually have the link if you want the link for this. Well, I could share that later. So let's just go. Take the first level here, hit play, and we want to do all the hard levels now. We did all the medium, we did all the easies, now I want to try all of the hard stuff. So the hard stuff is, well, the levels that are hard are kind of like harder to get to, and that's kind of intentional. The idea is you gotta work for it to get to them, and I don't think this is going to be... Okay, so that's interesting. So let's think about this for a second. So we can go down here, that's fine, we can stay right here, and it looks like we can just run through this, right? Because it looks like we can just run through here and just get through here safely, right? But we see these bombs right here are setting a trick trap for us. We gotta go like that. And then just wait for that to fizzle out. So that's an indirection kind of... the game design looks like it wants you to do one thing, but it's actually a trap. And that's just a thing to have fun. Now this is kind of like, I'm not a fan of pixel perfect kind of things like this. Especially at the end. Like, pixel perfect things at the beginning of the level are nice because you can restart really quick. But right at the end of the level, it's very punishing, and I don't like that punishing kind of design. I don't know what this is about. This looks like it was hacked together. I'm gonna hide up here. I'm just gonna go hide up here for a second and think about what I'm doing with my life. And we're just gonna continue just hitting things and hiding, because that's my main strategy. And it paid off. Okay, cool. And I don't know what's going on, but here I am up here. Oh, it's the hard level is up there. That's what's going on. So this is the hard level. Okay, so this is going to emit a spark if I hit this, and it's going to hit the bomb, and it's going to explode. So let's try to nick this up here. Okay, that's cool. Let's nick this one. Okay, let's just keep on doing it, and then let's see what our options are. Okay, so what are our options? Well, our only option is down here, so... let's hit this, and then we gotta jump up. Actually, no, let's not hit it. So it looks like this is a diversion, right? We think we can go down here, hit it, and then jump up, and that spark's gonna get us, so we might already be screwed. But let's try to run over here. Ah, we made it. Okay, cool. So, hit this, jump up before it gets us, and then... we'll just hit these, run over here. So some of these levels have this, like, surgical precision aspect, which is kind of ooh, there we go. Which is kind of annoying. It can be a fun game design aspect, but I'm not a fan of this level design. Yeah, okay, so this looks like a, ooh, this is a, This is a timer to our death. We're not gonna make it. We're not gonna... Oh, maybe we will. Maybe... Oh, no, we didn't make it. So, that's kind of annoying because we do all that hard work. And then, you know, actually, let's go this way. This way is gonna be easier. Okay. We did all that hard work, and then that was supposed to be a more fun kind of thing. I don't think it's supposed to be timed where it's, like, impossible to make. It's just I wasn't paying attention, and then it just got me. So, let's do this again, and this time, not get ourselves killed. Ooh. Oh, I didn't realize we could... Ooh, this might be... Sure, we can go over here. And if we hit this, this is going to hit... The chain reaction will have already started once we hit this. Can we buy ourselves more time if we blow this up? No, we can't, because these are all invincible tiles over here. So, we just got to go down here, and then we have to... Really? Oh, well. Well, if that's the way it works, then that's the way it works. Oh, this is an invincible tile. Okay. So, now, we gotta run and get up there in time. So, let's do this. Let's do this correctly this time. And not wait around and dilly-dally, because I don't think it should be too hard, right? We got killed right up here, so there we go. Then you can kind of wait. There we go. This is kind of... Ooh, no, these are wrong way. Oh, no, not wrong way. Okay, yeah. So the little explosions aren't big enough to get to the instant kill bomb, so I think... You know, let's just do this. I don't want to deal with that. Let's just do that. That might actually be the solution. I don't... Ooh, no, let's hide over here now. Okay, so open that up. Open this guy up. Oh, this might not have been the... Ooh, okay, okay. Well, we made it, so that's cool. And... Yes. Oh, come on. Okay, so we know what you need to do, right? So let's just do it. But we have to wait. That's the thing here. Okay, so we actually have to think about what we're doing here. We can't just mindlessly touch things and run away. We have to touch things in the right spots. So for instance here, it's going to be much easier to... Well, actually, we don't even have to think about this. We can just run away over here. But in this next section right here, it's going to be easier if we touch this, run over here, and then jump. Okay, there we go. Then this was pretty easy. It was that last part, right? We got killed over here. So we should just be able to kind of... Okay, so this bomb right down here is going to shoot straight up through here. So we have to nick this lever on the edge, or else I think it would get us. It might not, I'm not sure, but it looked like it was going to get us. So this, we could jump all the way down there, but we want to take the hard path. The hard path doesn't look any different. I mean, they all look equally easy to get to, unless there's something I'm missing here. Oh, do we seal it off? We might be sealing it off. Oh, I see. So the hard path gets sealed off, doesn't it? No? I think maybe the intention was to seal off the hard path. Anyways, let's just go there. So this looks like a death trap, right? Because all these are vertical. And there's no way out of here. So it's like a pit, bottomless pit with the bottom. So we just want to get through here. And it looks like we gotta run... They don't chain react together. We just gotta... Yeah, there we go. Okay. So this... Ooh, what... Huh. This doesn't look possible. Oh, wait. It is this. You gotta hit the ceiling. Okay, cool. And we could hide up here. Okay, not bad. But this is a soft lock, yeah? This looks like a soft lock, because we are stuck here and we can't get out, can we? Yeah, we can't get out. So let's reset this. I'm sure there's a solution here. So it looks like we want to get each one of those. If we do the most naive thing, then I'm assuming we'll be able to make it through. Oh, Oh, you know what? We need to save a spark for right here. Because if we save a spark for right here, we can actually open up that up. So let's reset that. We know by the vertical one, we need to save that spark somehow. So we don't want that spark to go off. So this thing, we don't want this to go off. Oh wait, there's no spark. There's nothing to spark here, though. We can go here, or we can go here. So if we wait for this to fall somehow, will that ever fall? It'll never fall. Yeah, I gotta say, I don't know. It doesn't look like... Right? Nothing is gonna hit that. Okay, so this looks absolutely hard-locked. Did I really design a level that just hard-locks like that? Or... is there another way to open all this stuff up that doesn't do that? Well, no matter what we hit here... it could depend on what we... if we nick things... if we nick everything a little bit and kind of save these, maybe we'll have more options, maybe? Okay, do we have another option now that will... no, there's nothing here. There's nothing here that can go down there. But we can still hit this, so maybe that opens up an option? Yeah, that's like... that's a total... okay, so that's stupid. So the game is lacking in polish there. Some of these levels I'm gonna guess were just kind of thrown together. What about these? Can we... so hard shouldn't be impossible, obviously, right? So this is interesting, right? It's kind of teaching you something about how pixel perfect you can be, so that's kind of cool. I like that. Right, because we can kind of get really close. We can get really close, but as long as we're not touching it, we're fine. And it kind of forces you to get really close. So we gotta... that's kind of cool. Let's hit that. Let's hit these. And do we have a hard door and an easy door? Oh, no, we just have one little exit door. That exit door looks a lot different. Is that like an end game door or something? Do I have an end game door? Well, it doesn't look like any of the other doors. Oh, maybe I made a, to accommodate the level design, I think I may have made kind of like a custom smaller door to accommodate some of the level designs. I think that's what's going on there. So let's try to hit that bottom lever. That bottom lever looks like the one we want to hit, so let's try to run through here and not die. Come on, jump at the... ooh, we got really lucky there. And did we get so lucky that it was supposed to kill us? I don't think so. Or maybe, I don't know. Let's hit these, let's wait over here, and let's think about what we can do next. So we cannot hit this lever, or can we? I don't know if I was supposed to be able to do that, but we just did. So let's hit this. And are we good to go? Are we out of here? Yep, we're... no. Oh, no, it sealed off the exit. That's cheap. Oh, wait, no, we can still do it. We can hit this. We gotta hit this. And that will open up the exit. Okay, cool. So now the exit door is open. Okay, so this thing, kind of a fun little thing. We've done this before. Just let him go off and die, and then we'll exit. And more of these guys. You seal... oh god, timer. So we have a little timer to your death here. So we want to figure out how to... okay, so that's interesting. So there's nothing down there, and we want to somehow get through here. And I have no clue how that's going to be done. Let's just open this up and think about it. I guess if we had a way to get sparks down here, that would work. Well, let's, well, now we got the pressure. So, okay, so it looks like it doesn't fall open completely symmetrically, so maybe as it falls, we have to, like, skirt through everything. But this thing is gonna be... Oh, hey, look at that! So it's a death trap, but we can get through... Oh, I see. So it kind of... Huh. Whatever, well, we're through, so... Not gonna worry about it. Okay, that's interesting. So... And... So this thing... I thought bauxite leaves a platform behind, right? Yep, it does. Okay. Or... Ooh. Okay, so this guy probably must lay bombs. Because I can't. Ooh, there we go. Nice. Okay, so this. They're gonna lay some bombs. They're gonna die. Or they're at least gonna be gone. And are we locked out? No, we're not locked out. Okay, cool. And then we just gotta run through here fast enough and we'll be okay, so. Oh, I see. You gotta just get through here, because there's a crate falling. There's a crate that's falling through there, lighting up those bombs. You can't really see it very well, but... And this guy... Okay, he can be pushed into either one of these, but one of these is a wrong option, right? Let's do the wrong option first, just to demonstrate what's gonna happen. Right? So that bridge... Oh, we're gonna die here again, aren't we? Okay, so let's... Come on. Okay, so now, we're down here. We do not want him to hit that one. We want him to hit this one. Right? Okay. So after we're done with these, we'll be done playing all the levels for the final beta that we did before we kind of gave up on this game. And then we'll work on more of the engine stuff, or we might do another stream. So that's kind of crazy. Is this guy just a pushy guy, or does he also lay bombs? That would be a good thing to know, wouldn't it? It looks like he does lay bombs. Let's just wait for him to accidentally detonate one on himself, because I think you know, the AI isn't too smart. Or maybe he's just done. Oh, wait. Weren't we supposed to be doing the hard levels? And I see a hard door right there. Let's reset this. So, it locks you out of these doors if you do something wrong. And... let's not open up that case there. We need to get into here somehow. But if this bomb goes off, it opens this up and we're done for. Oh, so I think we have to light this up. We gotta light this up, and then once this opens up, we gotta slip through before it closes. And I did not... that kind of had some lag. I didn't see what was going on there. So... what the heck? Did it reload improperly? Okay, let's reset for a second. That seemed kind of weird. Okay, so now. Right, that closes it off. This closes the other one off, right? Okay, so now we have to hit this switch, get up here, and kind of wait. No, because we can't even jump that high. Okay. Let's reset this. So I do believe there is a solution to this. Oh, you know what it is? It's, let this guy do it. That's what the solution is. Oh, God. Oh, God. Okay, yes. So that is the solution. To let the AI guy do it. So, we gotta open him up, and then just let him do his thing. Oh, man, he is quick. He, like, does not waste any time. He does not waste time. It's unfortunate. Like, why does he not waste time? Why did I make him do... well, it is the hard door. It is the hard door, so fine. It's the hard door. Why? Of course he's not going to waste time. It's the hard door. If we could kind of somehow get him down there. Oh, that sucker punches me. So, I want to really do all of these hard levels, so, I mean, let's try to get through here, because the next button is not going to... Oh, God, this sucks. Okay, so, one of the things we really need here is some type of mechanic when an explosion opens up. When an explosion opens up a wall, that explosion should not be able to kill me. Like, right, that's just kind of stupid, right? Also, let's actually, do we have the mechanism to cheat still? No, we don't have a cheating mechanism. We can't lay bombs. So, we have to actually kind of... Oh, that is fucking stupid. Okay, so, we just gotta keep on keeping on, right? Yeah, that's not a good mechanic at all. Like, right, there's all this little polish here. That's definitely like a polish. That is a... So that's infuriating, right? It's completely infuriating, because you know exactly what you need to do, and you're kind of getting sucker killed by these, and that's not even the intent of the puzzle as far as I'm concerned. The intent of the puzzle isn't to kill you there, it's supposed to, like, make this kind of pressure thing, where it's like, you know, you gotta kind of... Right? Like, you win the game, and then it's the last level, huh? Little simple thing here. Okay. So we're done. We did all the stuff. We did all the stuff. Cool. So, and then we have like a little editor, right, where we can kind of put stuff, right? Auto-titling, right? So all the different materials you can put down here, and skull bombs, right? And you'll notice that we have a problem of the editor does not look like exactly like the game, right? And I don't even know what this is about. I guess I never used this material much. This is like a little billboard material where we can put like messages. And it wasn't really used much, was it? Probably because it looks ugly as hell. Right, we have all these different materials. We got 16 different materials, which was enough to make things interesting. And that's why the engine is going to really focus, the new engine is going to focus on just having 16 materials. Now, we do notice that, well, in addition to all these materials, some of the bombs are part of the material set. In the new engine, the bombs won't be part of that material set. They'll get their own 16 slots, I think. Because I think that this is a little bit cramped, where we have, like, if we wanted anything else, we would be in trouble. So we can, like, load this, right? And if we load this, I think we're in trouble, aren't we? Hey, what's this? What's up with this? We have slots here? What are these slots? Oh, nice. So we have little demo slots, right? I really like that transition. Nice. Empty slot. Right, this editor was half-baked. So the idea for the new game is to make it so that the engine and the editor are the same thing. So I'm going to stop this stream, and I'm going to start another stream where I can just go over this in a little bit more... a little bit of detail where I can just go over the editor really quick so that I have like a little clip that I can use for explaining this. So I'm going to stop the stream right now and I'll restart it. And also, actually, before I stop it, we're almost at 4 hours, which would be like 40 push-ups, 40 crunches, and whatnot. So let's look at our push-ups. Let's actually get that exercise done. So let's do 40 push-ups, 40 crunches, and 40 squats right now. So let's try to get some exercise. Let's do it. We could break it up into sets of 20, I think. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Crunches. Ugh. What the fuck? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, squats. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you want? 10. 11.
How many are you doing?
12. 20. 13. And
How
then
many? 14.
14.
How
And
many?
then 20 more each of thing.
15, 16, 17, 18, 19, 20.
And then push-ups.
Push-ups. 1, 2,
Two.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can do it. 17. Keep going. 18, 19, 20. You can pull 5 more.
No, it's crunches.
Oh.
2,
3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1.
crunches. Not crunches, squats.
Squats.
20 each.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Hey, you're past drug time.
Oh, I am? Okay.
Yeah, it's like almost 10.
Okay.
And there's food up there.
Okay, I'm gonna add the stream.
Dictionary if you want to join.
Okay, agenda screen. And then, let's see, agenda screen and, next time. So we're still doing PAINT5D, we just kind of have been taking some breaks to record like the Atomic Alice stuff. So, we'll do more stuff later.